Hello, and welcome to Beginning C++ Programming. Thank you very much for enrolling in this course and placing your confidence in the Learn Programming Academy team and in me for your training. In this video, I'd like to introduce you to the course, but first I'd like to introduce myself. My name is Frank Metropolis, and I'll be your instructor for this course. You can read more about me in the course bio, but I want you to be sure that I will do everything I can to make sure the course content is correct, relevant, understandable, and hopefully fun. I've been a university computer science professor for many years. I've also worked in industry as a programmer, software engineer, and project manager. I've taught thousands of students in both academia and industry how to program using many programming languages. But C++ is my favorite language to teach. I first learned C++ back in 1988, and I've used it ever since. That's quite a long time ago, and C++ has evolved greatly since then. I'm very excited to teach this course. I hope you're also excited about learning C++. In this course, I assume that you're completely new to C++. I also assume that you have little, if any, programming experience with other programming languages. If you do have programming experience, that's great. This course is still for you, since you'll definitely learn C++. The course curriculum has been developed in a way that introduces new topics in a specific order. I encourage you to follow along one section at a time. Before you know it, you'll be writing C++ programs that solve problems. In this course, I'll cover modern C++. I'll talk more about just exactly what modern C++ is as we go through the course, but rest assured that you'll be learning C++ as it should be used today. Over the years, I've worked with many students, and I can only remember a few that just didn't get programming. I still think that if they tried a little harder, then programming would have clicked at some point. If you're new to programming, you will at some point in this course feel frustrated. This is perfectly normal. Programming is a skill that must be learned and practiced. You play a musical instrument? Do you remember what it sounded like the first time you played? Do you remember wanting to smash that guitar or piano because you just couldn't get it? Programming is similar. You must practice and practice to get better. If you get frustrated, take a break and try again a bit later. Remember, we've all been there. I still remember the first program I ever wrote. It was back in 1980 using a programming language called Fortran 77. I was so excited that I was able to program a computer to do exactly what I wanted it to do. The program was pretty simple. It asked the user for an amount in US dollars and then displayed how many quarters, dimes, nickels, and pennies it would take to add up to that entered amount. We'll do the same problem in this course. I also remember that it took me maybe more than a couple of attempts before it was correct. But man, what a great feeling when it ran correctly. In this course, each section ends with a challenge exercise. These will help reinforce the concepts presented in this section to help in learning the material. Once you finish the challenge, don't stop there. Challenge yourself. Come up with similar problems on your own and solve them. Then do it again and again. Make it fun. Make the problem silly if you want to. It doesn't matter. It's all about practice. Finally, if you have any questions at all, please ask them in the forums. I will personally monitor the forums and respond to questions. Before you post, though, browse the already answered questions, since your question may already have an answer. Well, enough talk. I look forward to working with everyone. Let's start learning C++. One question that students often ask when they're considering a career in software development is, what programming language should I learn? There's really no easy answer to that question. Experienced professional programmers generally know many programming languages and use them based on many factors. The question I'd like to address in this video is, why learn C++? Let's start with C++'s popularity. Much, if not most, of the software written today is still written in C++. And this has been the case for many years. There are many programming language popularity indexes that use different criteria for ranking the popularity of programming languages. Let's head over to a browser and we'll look at a few of them. I've opened up a browser and I've loaded several sites that rank programming languages based on popularity. All of the data I'm showing is current as of November 2017, so depending on when you access the site, your results may differ. Each site uses their own criteria, and I encourage you to browse through these sites. I've provided the URLs for these sites in the course resources. First, let's look at the TOB index. As you can see, C++ is currently ranked 3rd. If you select that row, You can learn more about C++'s popularity since 2001. It's pretty impressive for a language to be ranked so consistently for so long, considering how many new languages and frameworks appear on the scene. The next site is the PYPL Popularity Index. As you can see, C++ is currently ranked 6th. Next, we'll look at the IEEE Spectrum rankings. On IEEE Spectrum, C++ is ranked number 4. The RedMonk ranking has C++ at number 6. And finally, we'll take a look at ZDNet's rankings. They combine popular indexes and create an ensemble ranking which shows C++ at number 4. They also provide an analysis of the data that's a good read. Let's return to the slides. As you can see from these sites, C++ is still a very popular language among software developers, and the ranking is consistently high. If you go to GitHub, you'll see that there's a huge number of active C++ repositories, and C++ is also extremely active on Stack Overflow. Popularity is important, but C++ is also a relevant language. There are many leading software titles written entirely or partly in C++. These include the Windows, Linux, and Mac OS X operating systems, many of the Adobe products such as Photoshop and Illustrator, the MySQL and MongoDB database engines, and many more. Leading tech companies use C++ for many of their products and internal research and development. These include Amazon, Apple, Microsoft, PayPal, Google, Facebook, Oracle, and more. Finally, the types of projects that C++ is being used on are pretty cool. In many cases, these are the engines that drive many popular frameworks. For example, engines for virtual reality, the Unreal Game Engine, machine learning, network and telecom, and more. There are many reasons why C++ is so popular and relevant, but the main reason is because it's so powerful. What do I mean by powerful? C++ is super fast. It's a general-purpose programming language that supports both procedural and object-oriented programming, making it very flexible. It scales easily, and it can also be portable. C++ can do many things that other languages just can't. That's why nearly every major language has a way to interface with the code written in C++. With all this power and flexibility comes complexity. There's no question that C++ is one of the most complex programming languages out there, but learning the basics is pretty easy, and that's what this course is all about. Finally, you've probably heard that C++ programmers command higher salaries. This is true. You may have even heard the phrase C++ equals salary plus. Career opportunities are out there for C++ programmers. I've consulted for many years with major U.S. corporations on the hiring of software developers. This includes full-stack developers, Java developers, iOS and Android developers, and C++ developers. Having C++ skills on your resume is often like a badge of honor among software developers, and many times it'll get you that job interview. Why? Because C++ programmers have a skill set that sets them apart from many other programmers. One final thought. Since so many programming languages are influenced by C++, learning new languages is often easier since you already have solid foundation in a root programming language like C++. As you can see, you've made a good choice in learning C++. In the next video, we'll briefly look at the evolution of C++ and the C++ standard. In this video, we'll take a brief look at the history of C++ based on some major language milestones. In the early 1970s, Dennis Ritchie created the C programming language at Bell Labs. The development of C was closely tied to the development of the Unix operating system. In 1979, Bjarne Stroustrup started working on what became C++. He initially called it C with classes. His idea was to add to C object-oriented features that he knew from a language called Simula. In 1983, the name was changed to C++, and the first commercial release was in 1989. In 1998, the C++ Standards Committee published the first C++ standard, informally known as C++ 98. Multiple issues with C++ 98 were addressed, and the C++ 03 standard was released. Then in mid-2011, the C++ 11 standard was released, and then after that, C++ 14 and C++ 17. As you can see, C++ has been around for quite some time. Notice that I've bolded and italicized the last three standards. These standards are sort of a renaissance for C++ that changed the language going forward. These changes are what modern C++ is all about. Generally, C++ that's based on the language as defined before the C++11 standard is considered classical C++, and C++ based on C++11 and forward is considered modern C++. That's fine, but what does that mean? Well, modern C++ is a way of saying that it's C++ as defined today, with new ways of managing objects in memory, lambdas, smart shared pointers, threading, and more. These terms may not mean anything to you yet, but modern C++ feels like a new programming language when compared to classical C++. In fact, Bjarne Stroustrup described modern C++ as a new language, one with modern abstractions for ease of use and power. Along with the language features themselves, modern C++ is also about best practices and core guidelines. In this course, we'll be using modern C++. As we go through the course, I'll sometimes mention that this feature was introduced in C++11 or C++14 and so forth. I'll do that for a few reasons, but the most important is so that you know where to look for this feature as your C++ studies continue after you finish this course. I'll also show you best practices and gotchas that you should be aware of. If you're new to programming, you may be wondering how all this works. After all, it sometimes seems like magic. How can we get a computer to do what we want it to do using a programming language? Let's see in the next video. In this video, we'll take a high-level look at how all this works. If you're completely new to programming, then many of these terms will probably be new to you. The most important thing to remember is that the computer isn't smart at all. It simply does exactly what it's told to do by the programmer. And the programmer in this case is you. A computer program is like a recipe. If you want to bake a cake, there are a series of tasks that you must execute in a specific order, otherwise the final product won't be a cake. Suppose that one of the tasks is to put 4 eggs in a bowl and mix. A human might assume that the number of eggs need to be cracked and only the egg whites should be used. But that's not necessarily true. They might assume something else. See, that's the problem. A computer would probably put the eggs, shells and all, into a bowl and mix them. So when we write programs, we need to be very, very explicit about what we want the computer to do. Otherwise, our result will probably be incorrect. In order to write programs, we use programming languages. There are many, many programming languages out there. In this class, we'll be using C++. The code we write is called source code. Source code is generally higher level than computer code since it needs to be understandable by humans, and humans aren't very good at reading long streams of zeros and ones. We write our programs using programming editors. These editors are like word processors specifically designed to write these recipes in a specific programming language. C++ programs have an extension like .cpp, .h, .cc, .hpp, and there are several others. In this course, we will use .cpp and .h as the extensions for the code we write. Just as humans aren't very good at reading computer code, computers aren't very good at reading source code. We need to translate the source code to a form that's understandable by the computer. This form is called object code, and the compiler is the translator. The C++ compiler is a program that takes as input C++ source code and produces object code as output. If the source code has errors, then no object code is produced. Since our code might depend on code that other programmers wrote, this is actually a very likely scenario because we want to reuse as much existing code that's out there as possible. This makes it easier for us to solve our problems. So a program called a linker takes our object code and the object code that exists out there in the form of libraries and links it all together to form an executable program. That is a program that we can now run that follows the recipe we told the computer to do using C++. Now that our program is complete, we test it to find as many errors as possible, and we debug it to eliminate those errors. As you can see, there's a lot going on, and understanding what's going on at this high level is important. The integrated development environments are programs that allow you to do everything I just mentioned from a common interface. Sometimes they make the process seem like magic, since all you need to do is click a button and the entire build process happens. Let's go over this build process one more time in a visual manner. First, we use an editor to enter our C++ code or to edit existing C++ code. Note that we can have many C++ source files. In this course, we'll be using a single main.cpp file until our programs get larger. Then we'll need several C++ source files to better organize our program. Production C++ programs can have hundreds and even thousands of source files and millions of lines of code. Then we need to compile the C++ code using a C++ compiler. If the code contains no syntax errors, then the compiler will generate an object code file for each C++ source file. On Windows, the object files have .obj extensions, and on Unix and Mac, they will have .o extensions. Finally, the object files and any libraries that our program requires must be linked together. This final step creates an executable file that can run. On Windows, the file extension will be .exe, and on Unix and Mac, they typically don't have any extensions. But remember, we're not done yet. You must test your program to find any logic errors and debug it to eliminate those errors. Let's wrap up this video by looking at some of the available IDEs that can help us with this process. As mentioned previously, IDEs are programs that provide an editor, a way to compile, link, and execute your source code. They also often have debuggers that can help you understand your code and fix errors. Most beginning C++ courses don't cover integrated debuggers at all. I think this is a mistake, and I plan to cover the debugger once we have the basics of C++ behind us. IDEs also help us keep our files in sync and provide hooks to version control systems such as Git and Subversion. There are many IDEs available. I've used all the ones listed here and others. The selection of an IDE for this course was not an easy one. I wanted an IDE that was free, cross-platform, and had a relatively small hardware requirement to run. In this course, we'll use CodeLite as the IDE since it meets all of these criteria. However, there is no perfect IDE. As a professional developer, many times you use whatever IDE is used by the team you're working with. As a consultant, you should learn as many IDEs as you can and always have an editor command line preference available as well. As you gain experience in C++, I encourage you to experiment with the various IDEs and find one that works for you. Let me talk briefly about the ones that are listed here. CodeLite, as I mentioned, is the IDE that we're going to use in this course. It's free, it's cross-platform, it's fast, and the memory requirements are minimal. CodeBlocks is also a nice cross-platform IDE. However, the Mac version is pretty buggy, and it kept crashing on me all the time. NetBeans is the Oracle IDE. It's used mainly to develop Java code, but they've got a plugin for C++ that's actually very good. It's a great cross-platform IDE. The problem is that it requires a Java JRE install, and the memory requirements can be pretty significant. Same thing with Eclipse. It supports many different languages. It's cross-platform, but it's got pretty good memory requirements. CLion is an IDE by JetBrains. This is a company that's created Kotlin, IntelliJ, Android Studio. This is an awesome IDE. This is my IDE of choice, but it's not free. It's actually quite expensive. But there's a download available that gives you a 30-day trial, and you can try it out and see if you like it. devc++ is a C++ Windows-only environment. It's small, it's fast, and it's a nice IDE, but again, it's Windows only. Kdevelop is a cross-platform, multiple language IDE. However, there is no Mac binary available. If you want to use it on Mac, you have to build it from the source. Finally, Visual Studio and Xcode are Microsoft and Apple's development environments, respectively. Visual Studio is a great development environment. It runs on Windows only in the C++ version. They have a Mac version of Visual Studio now, but it doesn't support C++. And Xcode is Mac only. Again, it's a great development environment. If you're a Mac developer, you're probably already using it for iOS development, Mac OS X development, Swift development, and so forth. But as I mentioned, it's Mac only, but it's a great development environment. There are many more IDEs available. If you find one you like and you think others in the course should know about it, please post that information about the IDE in the course forum. Well, that wraps up this video. I hope you now have a better understanding of the build process in C++ and how IDEs can help make programmers more productive. In this video, I'd like to go over the content in this section of the course. This is a very important section since we describe the installation of the tools necessary to create, build, and execute C++ programs. We wanted to make this course accessible to as many students as possible who want to learn C++. So, if you're running Microsoft Windows, Mac OS X, or Ubuntu Linux, we have videos detailing the steps necessary to get up and running on your platform. The following section includes videos for installing the C++ compiler and the CodeLite IDE on specific operating systems. Then we show you how to configure CodeLite so that it's using the C++ compiler we just installed. Then we'll go over how to create a default CodeLite project template that you can use when you need to create new C++ projects. This will make it very easy to start new projects quickly since all the required settings will be ready to go. In all the videos, we use a very simple C++ program to test the installations. All the elements of the C++ program will be explained in detail as we progress through the course. In this section, just type in the program and follow along to ensure your installation is complete. In addition to using the CodeLite IDE, we want to be sure that students can learn and build C++ programs even though they may not be able to install an IDE due to hardware limitations. So we created a section that uses just a simple text editor and the command line tools to do just that. If you're unable to use an IDE, then please don't let that stop you from learning C++. You can still use the command line just fine. Finally, we'll look at a few websites that have C++ compilers available that you can use to write and execute basic C++ programs. This has some limitations, but it's great if you're on the road or away from your PC. All you need is a web browser, and you can run much of the code presented in this class. Remember, websites, software versions, and tools change over time. If there are any changes that are important, I'll post the information in the resources section of the specific videos. So if a new version of CodeLite is released and it's different from the previous version, I'll post an update in the resources section explaining how to use the new version. This allows everyone to carry on using the new version while new videos are recorded and uploaded. Okay, so go to the videos that apply to your operating system. We'll get started installing the tools we need to create C++ programs. I'll see you there. In this video, I'll take you through the steps necessary to install a C++ compiler for the Windows operating system. We're going to install the compiler that's located at mingw-w64.org. I'll provide this URL in the resources section for this video. Open up your favorite browser and enter the URL mingw-w64.org, and you'll get a website that might look like this. Websites change over time, but this is what it looks like as of March 2020. What we want to do here is we want to click on Downloads. So I'm going to click on Downloads, and we've got a whole bunch of options here. What we're going to pick is this one right in the middle called mingw w64 builds for Windows here. And this is a C, C++, and Fortran compiler all built into one. It's a GCC compiler, which is really a collection of compilers. So what I'm going to do is I'm going to click that link right there, and then I get sent to this page, and finally I'm going to go to SourceForge. And when I go there, we're going to get the download. So I'm going to click on that, and the download should happen automatically. You can see here your download will start shortly. Here's the download down here at the bottom of my Chrome browser, and it's done. So at this point, you can see that I've got my mingw w64 installer ready to go. You can see my antivirus just popped up a little message here that says that it's safe. And what I'm going to do is I'm just going to double click on this to install it. So in this case, I can come over here and select downloads and run it from here, or I could run it down from the bottom. I'll just double click here. I'm going to allow it to make changes to my system, and I'm going to minimize my browser just to get it out of the way. So this is the installation wizard right here. It says, welcome to the mingw w64 installation. Now, the MeanGW compiler will install a 32-bit compiler or a 64-bit compiler depending on your operating system. So the first thing we need to do is you need to see what kind of operating system you've got. Is it a 32-bit Windows operating system or a 64-bit Windows operating system? There's a really easy way to tell is just to come over here, and right in here we're going to type Control Panel, and we're going to go to our Control Panel, System and Security. And then right here where it says System, you can click on there, and you can see right in the center here where it says System, you can see that my system is a 64-bit operating system. So I'm going to install the 64-bit compiler. If yours says 32 bits, then you can install the 32-bit compiler. And I'll show you how to do that in a second. But this is important. Make sure you remember this, because when we install our CodeLite integrated development environment in the next video, we're going to use this information again. So write that down. So I know I've got a 64-bit operating system. So I'm going to close this down now, and I'm going to go through the installer. I'm going to select Next. And what I'm going to do here is I'm going to install the latest version. You can click on here and get whatever version of the compiler you want. I'm just going to stick to the latest, which is 8.1.0 at the time of this video. It might be 8.2, it might be 9.0 by the time you download this. The architecture, this is where the 32-bit, 64-bit comes to play. So I'm going to click right there, and you can see i686 or x86_64. This guy right here, i686, that's the 32-bit version. That guy right there, x86-64, is the 64-bit version. That's what I'm going to choose. Now, if you're on a 64-bit machine, it will definitely run the 32-bit version, but you might as well use the 64 since that's what you've got. The rest of the stuff, you just leave it alone, and I'm going to select Next. Now it's going to ask me where I want to put it. I really don't like this huge long name that it's got here, so what I'm going to do is I'm just going to erase that and just take it all the way down to the Ming64, right? MeanGW64, right about there. Okay, so that's where I wanted to install my files. It's very important when you name your directories to be sure that you don't use any special characters, no international characters, and no spaces. So make sure that whatever you decide to use for directory names, they're very, very simple, because compiler toolchains have real problems with cloud drives, spaces, international characters, and special characters. I'd like to create a shortcut in the Start menu, so I'm just going to select Next. And at this point, the installation is just going to go on its own. Just leave it alone. Take your time. It doesn't take that long, probably just a couple of minutes. And then once it's installed, what we'll do is we'll do one more thing we need to do. We need to change our path variable so that Windows can find this. Okay, so the installation is complete. I'm going to select Next and Finish, and we're done. Now there's one more thing we want to do. We want to set the path to what we just installed in the Windows path environment variable. So how do you do that? Well, you go to Control Panel again, and right up here in the Search Control Panel, I'm going to type ENV for environment and press Enter. And you'll see it says right here, edit the system environment variables. That's what I'm going to choose. Now this is what you see in Windows 10. If you're running Windows 7, please refer to the resources section for a PDF file that shows you how to do this there. So I'm going to select edit the system variables right here. And I get a systems property. Let me reduce this so it doesn't clutter up the screen. Now down here at the bottom, there's a button called environment variables. That's what I'm going to select. Now here are my environment variables. We've got variables for the user and system variables. We could really do this in both places, but I'm going to do it in the system variables area down here. I'm going to select path, just like that. And then I'm going to select edit. Before you do anything here, be very, very careful not to delete anything. We're not deleting anything in our path. If we delete stuff in our path, we could really mess up our system. So be very, very careful here. I'm going to select edit, not delete, edit. So I'm going to select edit, and I get a little screen like this. Now these are my current path variables right here. What I want to do is I want to add a new one that points to what I just installed. And I'll show you how to do that here. We're going to select New. And right here, we're going to browse. And I'm going to go to where this was installed. So it was installed in this PC. It was on the C drive. It was in Program Files. And it was in MinGW64. You see right there? And what we're going to do here is we're going to select the bin directory. That's the binaries. That's where all the executables are for the compiler. So make sure that that's selected. Click OK. And you can see that the path has been entered here. Now, what I like to do here is I like to move this up in the chain. So I'm just going to select it and then move up a few times just till it's just below these System 32 ones right here. At that point, I'm done. I'll select OK. I'll select OK again. And finally, OK one more time. Now, let's do a quick test to make sure that we installed this correctly and everything is running. What I want to do is I just want to type CMD here so I can get a command prompt. That will open up a window. And this is your command prompt window. You can type commands in here. So what we want to type in here is we want to type G++, all lowercase, the lowercase g like that. G++, followed by a space, and then dash, dash, version. So again, G++ space, dash, dash, version. And when I press enter, you should see something like this. It says G++, that's our C++ compiler, and 8.1, which is the version that we installed. Now, if you do G++ dash, dash, version, and you get something that looks kind of like this, some gobbledygook that says it's not recognized as an internal or external command, then what probably happened is that the path variable is not set correctly. So back up, do that again, be real careful and make sure you selected that bin directory and that it's all good to go. So at this point, we're good to go. Our compiler is installed. The next step is to install our CodeLite integrated development environment. That's going to allow us to write C++ programs, build them, and execute them. So I'll see you in that video next. In this video, I'll go over the steps necessary to download and install the CodeLite integrated development environment for C++ on the Windows platform. CodeLite is a free, open source, cross-platform integrated development environment that works across Windows, Mac, and Linux. And this is the IDE that I'm going to use in this class. In order to download it, open up your favorite browser and go to codelite.org. That's CODELITE.org. And you'll get a page that's similar to this. As of this recording, the CodeLite version is 14.0.0, and that's the one we want to download. Now we can download up here by selecting that download link, or we can click this big green button. Websites change over time, so as CodeLite gets released and newer versions get released, this website could change, but hopefully there'll still be download links around there. So I'm going to select download CodeLite 14.0.0 here, and it takes you to this page where you can support the developers if you wish, or you could just click right here, not now, take me to the download, and that's what I'm going to do. And we've got some options here. Right now, we've got the CodeLite 14.0.0 stable release, which is the latest release, as I said, at the time of this video. And we've got different options for Windows, for Mac, and for Linux. And I'll cover the Mac and Linux versions in separate videos. But what we're going to do here is we're going to install the Windows installer. So do we have a 64-bit or a 32-bit system? If you go back to the previous video where you installed the C++ compiler, I showed you how to check that on your PC. This PC has a 64-bit installer, so that's what I'm going to choose. If you have a 32-bit version of Windows, you'll want to choose the 32-bit installer. Okay, so I'm going to select that link, and that's going to download the CodeLite installer. You can see it downloading down here at the bottom. It's not a very big download at all, 33.3 megabytes. And once it's complete, what I'm going to do is I'm going to come up here to my downloads, and I'm going to run it. And I'm going to close down my browser window. I'm going to let the program make changes to my system. Again, you can see my antivirus here telling me it's safe. Sometimes antiviruses interfere with these downloads. If your antivirus is interfering with the download, just temporarily disable it while you do your download and install. So here's the setup wizard. I'm going to accept the GNU license agreement and select next. And this will set up and install CodeLight onto this folder in my program files called CodeLight. I suggest just leaving this alone. Don't put this on cloud drives. Don't put it on Google Drive. Just install it right on your local drive. And I'm going to select next. I'm going to give it the name CodeLight. I'm just going to accept all these defaults. And here I want to create a desktop shortcut and a quick launch shortcut. Whatever you like. This is a personal preference, up to you. Select next. And then finally press install. The install is very quick. And once we're done, it asks you to launch CodeLight, which is what we're going to do next. I'm not going to do that now. We're going to do that in the next video where we'll launch CodeLight and get it all set up, and we'll be good to go. I'll see you in the next video. Welcome back. In this video, we're going to configure the CodeLight IDE that we just installed in the previous video to work on Windows with the C++ compiler that we installed. If you haven't installed the C++ compiler, please go back to that video and install it, because we're going to have to need it installed in order to continue. So the first thing I want to do is I want to run CodeLight. I've got an icon here right on my desktop, so I'm just going to double click on that. Now, this is the first time I run CodeLight, and a lot of stuff happens. You get this setup wizard. You may get this little message at the bottom that says CodeLight now offers a better editor. So what I want to do is I want to close this wizard. I'm going to run that manually in a moment. So let's cancel that. And let's select yes down here so CodeLight can update our themes. So I'm going to select yes. And it says CodeLight restart is needed. Would you like to restart it now? Yes. And CodeLight will restart really quickly. You may or may not get that message depending on what the CodeLight developers do in the future. So now we're good. CodeLight is running. You can see that there's a lot of empty space here. We've got a workspace view here. We've got this big old space here in the center. And I'll explain what all of this is in a future video. I'm going to do a walkthrough of CodeLight, of the entire interface. But for now, what we're going to do is we're just going to get it set up and configured. So the first thing we need to do is we need to run that setup wizard, the one that I just canceled. So I'm going to come up here to help, and I'm going to select run the setup wizard. Again, help, run the setup wizard. And I get this little dialog box that says, welcome to the setup wizard. I do want to run it. You only need to do this once. So I'm going to do it the first time right now. I'm going to select next. Now it's going to ask me about my development profile. The CodeLight IDE supports web development with PHP and JavaScript, as well as C++ development. So if you do both, you can select both over here. I'm only going to select C++ development right here, this option, and I'm going to select next. Now it says, do you want to set up a compiler? I don't want to install a compiler. I've already installed it. So what I want to do is select scan. What CodeLight will do is it'll scan my system for installed compilers and set them up for me automatically. It's important that we set that path variable. Remember when we installed the compiler, CodeLight uses that path variable to find the compiler. So if we scan and it can't find the compiler, either it's not installed or the path variable is incorrect. So I'm going to select scan. And you see it found my MinGW64 compiler that I installed, and you can see the installation path. I'll select next. That's it. Now we're going to customize our colors. You can use the system default, or you can use the dark. The dark is pretty nice and easy on the eyes, but I don't think it shows up too good on video. So I'm going to stick to the system default for the video and select next. These settings here for spacing and indentation, just leave those as the default. And select finish. Okay, it's going to close and restart, and we're going to get this same interface again. Now we want to double check that the compiler was set up correctly. So we want to go to settings and then select build settings. And you should see MinGW64 here when you select the compilers tab, and you should see all the paths to the compiler, the linker, the assembler, all this good stuff that we'll talk about later. Okay. If this is all empty, then the compiler was not set up correctly. And you really need to go back and double check that path variable. Okay, so at this point, we're good to go. We're done with the installation and the setup of the compiler. Now what we're going to do is we're going to write a real simple program just to be sure that all of this is working correctly. So the first thing we want to do is we want to create a new workspace. And I can create that right here. I can click on New Workspace, or I can come up here and say Workspace, New Workspace, either place. Now, the idea behind a workspace is an area, and it holds projects. So we can have a single workspace that contains many projects. And that's the way that I've set up the source code for this course. The source code is located in the very last section of the course, and it's organized into workspaces. So you can download Workspace for Section 5, and it's going to have all the projects that I did for Section 5. It's a very nice way to organize projects. So again, it's just basically an area where you can have different C++ projects. So let's do that. I'm going to select New Workspace. And the first thing it asks me is, what kind of workspace? Is it a file system workspace or a C++ workspace? I'm going to select C++ workspace and click OK. Now it's going to ask me, where do I want to store it and what's the name of my workspace? Well, I'm going to store it in my documents folder, and I'm going to call the workspace first workspace. Okay. Now, I strongly urge you to click that, to check this little box right here where it says create the workspace under a separate directory. That'll really help you keep your files organized. So you can see what's going to happen. It's going to generate a file called firstworkspace.workspace, and it's going to be in this first workspace directory, which is exactly what we want. Now, there's a word of caution here. Do not use spaces here. Do not use special characters like pluses. I mean, don't do like something like C++ workspace. That's going to cause all kinds of problems. No international characters, no spaces. So keep the naming very, very simple. If your username, for example, my username here is Frank. If your username has special characters or international characters, then don't use it. Create this somewhere like CPP or somewhere else. Create it in a folder that doesn't have all of that in it. Okay? The last thing is, finally, be very aware that these compiler tool chains, which is what we're using, are very, very picky about names. Don't store these on cloud drives like Google Drive or Dropbox or OneDrive. They can cause a lot of issues. So again, store stuff locally. All right, enough said. So I'm going to store it in first workspace, and I'm going to select OK. Now you can see over here in my workspace view on the left that I've got my very first workspace. Now, in and of itself, the workspace isn't really doing anything for me. It's just a holder for projects. So what I want to do now is I want to create my first project. So I can right-click on the workspace and select New Project. So I'm going to select that. And now here we get a whole bunch of options. First, we need to name our project. So I'm just going to call it Project 1. Okay, again, you can name it anything you like. Don't use spaces, don't use special characters, don't use international characters. Check this box right here so it creates the project in its own folder. That's important. That way we can create many projects within the workspace and they're all nice and separated. Now we've got a whole bunch of options here. It's important that you choose the right options. The first one is the category. So I'm going to select that. The category is going to be console. You can see that there's a whole bunch of other ones. Console is the one we're going to use, which is basically a non-graphical user interface, and it's going to go to your command prompt. That's where the output's going to go. So console, the type of project is simple executable G++. Okay. Don't select any of these other ones. Those are all GUI based and CMake projects. We don't want any of those. We simply want simple executable G++. G++ is the compiler we're using. Now, what's the compiler? Remember, we installed a compiler and then we just set it up in CodeLite. So when I select this, it should show it to me. And there it is, MingGW. We can install multiple compilers on our system. If you do that, you'll get a choice here of 2 or 3 or 4, or as many as you've installed. I only have the one installed, so I'm going to select it. The debugger, select GNU GDB debugger. This is the one that's used in Windows. The LLDB debugger is the one that's used on Mac, but this is a Windows video, so I'm going to install that guy. I'm going to select the GNU debugger rather. And then finally, this one here is the most important one of all. You've got to make sure this is set to default. If it's set to anything else, you're going to run into build issues. So set it to default. And you notice that it defaults to CodeLite Make Generator. Don't select it, select default. And now we're good to go. So let me go through this because this is really important. This is where most of the errors come up with the projects. We name our project using non-international characters and so forth, as I've mentioned already. Create it in its own folder. The category is a console-based application. The type is simple executable G++. Compiler is MingGW or whatever compiler you installed. The debugger for Windows is GNU GDB, and later on in the course we'll use a debugger, and I'll show you how to use a debugger to find errors and walk through your code. And then the most important one, your build system default. Okay, so you can pause the video here while you set yours up and make sure you get these just right. Okay, so now I'm going to select OK. And when I do select OK, you're going to see a project being created over here called Project 1 in my workspace. So I'm going to select OK. And you can see that Project 1 has been selected. It has a source folder. And within it is main.cpp. Now, main.cpp or main.cpp is our C++ program, our source code. That's where we're going to type in our program that tells the computer what we want to do. Now, I can't see that source code yet, but when I select it, that source code will appear here in my editor. So I'm going to select it. I'm going to double click it, and you can see that it's right here. Now, we're going to erase this in a minute and write our own, but you can see that there's my source code right here. Now, it's pretty small because I just installed CodeLite. So I'm going to make this font a little bit bigger so it shows up better on the video. So I'm going to select, and you don't necessarily have to do this unless you want to, but I'm going to select colors and fonts. And let's see, I'm going to select, it's 9 points now. I want to select 16. That should be a lot better. So I'll apply OK. And hopefully that'll be a lot easier to read. Okay, so as I said, I'm going to delete this code right now, and we're going to write, this is actually C code. We're going to write C++ code. You're probably going to have a lot of questions. What does this mean? What does STD mean? What is all this stuff? Just follow along, type along. Let's get a clean build and run going. All of this is going to be explained in the course as we go through it. So let's do this. Pound include, and by pound, I'm using that hashtag symbol. Then I've got IOStream inside angle brackets. This allows us to do input and output. And then we're going to write our main function. Every C++ program has to have a main function. So it looks kind of like this, int, the word main, and then a left parenthesis followed by a right parenthesis. Then I've got a curly and a closed curly. An open curly, a left curly, and a closed curly right here, a right curly. Notice that when I put that left curly in, I'll do that again, and press enter, the integrated development environment automatically closed it for me. That's my main function. Now, within those curlies, I'm going to type std followed by 2 colons, followed by cout. No spaces, just std, 2 colons, cout. Then I've got 2 less than signs, side by side, no spaces between them. And then I'm just going to say hello testing. And all of that is inside that double quote character. It's not 2 single quotes, it's the double quote character. And then I'm going to say again, less than, std, endl for end line. And then the whole thing ends in a semicolon. It sounds like a lot. All we're doing is we're displaying hello testing to the console. That's all we're doing. Cout is the console. End line puts a new line at the end so that we go to the next line. Okay. Again, I'll explain all of this in the next couple of sections. So now what I'm going to do is I'm going to type return 0. That tells the operating system that our program worked correctly. Perfect. Now I need to save this. You'll notice this red bar right here that's going from 1 through 6 right there. That's red. That means that none of this has been saved. So I need to save this. I can come up to File, Save File, or I can press Control S. I'm going to just click there. Notice that that bar is now green. That means that you have saved your program. Okay, now we're going to build and run this. So we're going to come up here to Build and Run. But before we do that, we need to set up a couple of things for our project. We want to use modern C++. We want to turn on warnings, and we want to do a couple of other things. So how do we do that? I can select my project right here, and I'm going to right click, and I'm going to come down to Settings. And then I've got all these options. Luckily, we don't have to change too many of these. This is already set up. That project wizard that we just did to create this, where we chose console and simple executable and default, all that, that's filled all of this out for us. What we need to do is we need to come to the compiler one right there, that link right here. And we need to make a couple of little changes. We're going to come to the C++ compiler, not the C compiler, but the C++ compiler. And I'm going to select that right here. Notice those three little dots that show up over here, that little button. I'm going to select that button, and I'm going to select Enable C++ 17 features right here. In this video, the majority of the videos that I've done are using C++ 14 features. You can choose 14 or you can choose 17. Do not choose both. That will really confuse the compiler. So I'm going to select C++ 17 features now. And notice what's down here, W all, which turns on all your warnings. And I've got a -G and a minus optimization here, the big O. That's it. That's all I really need to do. So you want to make sure that you enable all the compiler warnings, enable C++ 17, optimize for debugging, and produce debugging information. That's where all that's coming from. That's all we need to do. I'm going to select OK now. And one more thing, come to the linker. And then where it says linker options right here, you could just type -static. And then we can apply. You don't have to do static, but a lot of errors can come up without static, and it's a lot easier just to learn C++ without those errors. And if anybody has any questions about that, you can ask me in the forums, and I'd be glad to get into more detail. That's it. I'm going to apply, select OK. Now we're ready to run this. Again, make sure this is green here. It's good to go. So I'm going to come to Build, and I'm going to select Run. And here I've got the choice of executing it or building it and executing it. Again, I'll talk a lot more about the workflows in future videos, but we want to build it and then execute it. We want to compile it, obviously. We have to compile this so that the computer can run it. So that's what I'm going to do. I'm going to select Build and Execute. Down here at the bottom, you'll see a bunch of stuff happened, right? This is my output, and this is my build. And you probably saw that little console window a second ago, and you can see it says, hello testing. That's exactly what we want. Our program worked correctly. So this is being compiled and executed. We've got a command prompt window opening up, displaying the text. It says press any key to continue. I'm going to press enter, and the window will close. And it's gone. And down here is the output view. Now, there's a whole bunch of stuff here. We really aren't going to talk just about one or two of them. The only two we care about are really build and output. And you can drag these around and put them wherever you want, but build tells you what's the build. Here you can see my compiler is being executed, and it's compiling stuff, and it's doing all kinds of stuff. So if you run into compiler errors and issues, they're going to show up here. If in the forums you'll post something about something not quite working, I might say, show me your build output. This is what I want. I want you to grab this stuff right here and copy it in there, or just give me a screenshot and post it. That'd be really, really helpful. Now, what can go wrong? Well, let's say you forgot this semicolon. And notice that little red bar there, right? That little piece right there says that that's been changed. So I'm going to save. I'm pressing Control S here. Now it's green. I can go to Build, Run, build and execute. You can click on there if you like, but don't do that yet. We'll do that in a future video when I'll show you more about building. Build and execute. Aha, see the red? That's an error. It says, error, I expected a semicolon. Like, hey, you forgot to do the semicolon. Notice this is red. Notice that if I click there, it takes me right to the error. There's a red arrow right here, and it's telling me, obviously, I forgot the semicolon. So I'm going to save again. What else could go wrong? I forgot this quote mark. Again, I'm going to build and run. Well, an error, right? Double click. Oh, I'm forgetting that. So these errors, I'll talk about different kinds of errors, common errors, again, in a few videos. The other thing that I've seen that's common is to put a 0 here instead of 2 parentheses. These are 2 parentheses, not a 0. I know they look very, very similar sometimes when you do the 0 like that, but there's a left parenthesis followed by a right parenthesis. Okay. Main must be spelled correctly, and IOStream. Sometimes students will forget the R, and you'll see IOSteam. IOSteam, the compiler will have no idea what that is. So if you build and run, that's it. No such file. You're going to get all these errors. Like, I have no idea what's going on. So you can fix that as well. It should be IOStream. So that's it. This is configured now. Let me build and run one more time. Make sure we got rid of all those errors. That's it. We have a clean build down here. Notice 0 errors, 0 warnings. And I've got a clean run. Hello testing. Press any key to continue, and we're done. All right, so that's it. We're good to go. We're ready to start writing C++ programs, and I'll see you in the next video. In this video, we'll go over the steps necessary to install the command line tools, which includes the C++ compiler on the Mac OS X platform. I'm running right now Mac OS X 10.15, which is Catalina. So in order to do this, we need to open a terminal session. So that's what I'm going to do. I'm going to come up to Spotlight Search here and just type terminal and press enter. And that will open up a terminal. Now, one of the things that's changed in Catalina is that the default interactive shell is now Z shell. Actually, I'm running the born again shell right now, bash. So this is why I'm getting this message. You can keep using bash if you want. I really don't want to see this message all the time, so I'm going to switch to the Z shell. And it basically tells you right here how to do it. It says run that command right there, which is the change shell command. So that's what I'm going to do. I'm just going to type CHSH for change shell space -s, and then bin/ZSH for the Z shell. I'm going to now press enter, and it's going to prompt me for my password, which I enter, and we're done. Now you'll notice I'm still running the born again shell, right? So I'm going to close the terminal session and open it again. And now I'm running the Z shell, so you can see right there. I won't get that annoying message anymore. Okay, so let's install the command line tools. There's a couple of ways to do this. We can type xcode-select, all one word, no spaces, followed by a space, and then --install. That's xcode-select space --install. And when I press enter, I'm going to get a pop-up window here that says, do you want to install the command line tools now? And you can just click install and you're good to go. If you get a message that says that the command line tools are already installed, then you're pretty much good to go already. The only thing you need to do is keep them updated through the App Store. And I'll show you how to do that at the end of this video. So I'm going to cancel. Another way you can do this is just to type G++. And since G++ is the C++ compiler, when I press enter, it's not there, so it's going to tell me, do you want to install it? I do, so I'm going to select install. I'm going to agree to the license agreement, and then it's going to go off and download the software and install it. This takes a little bit of time depending on your internet connection. So what I'm going to do is I'm going to pause the video and I'll be back. You can see here it takes about a minute on with my connection. It might take a little bit longer. So I'll pause this and I'll be back in about a minute. Okay, so the install took about 4 minutes on my end. And now you get the pop-up that says the software was installed. So I'll select done. And we can do a quick test by just typing G++ space -- version. Again, that's G++ space dash dash version and press enter. And we should get something like this. Your versions might be a little different than mine, but it's good to go. We're installed. Our command line tools are ready to go. The other thing you can do now is you need to keep these tool chains updated. So you need to do that through the App Store. So you'll come up here to the Apple and we'll go to App Store. And if you go to updates, you'll see any updates that need to be done here. There are no updates now because I've just installed the latest and greatest. And that's pretty much it. Our compiler is installed. The next step is to install the CodeLite integrated development environment, and we'll do that in the next video. Okay, so now that we've downloaded and installed the command line tools and the C++ compiler, we're now going to install the CodeLite integrated development environment. And CodeLite is an open source, free, cross-platform integrated development environment. It works with C, C++, PHP, and JavaScript. We're only going to use the C++ side of it. It runs on OS X, Windows, and Linux. So once you learn it on one platform, it's really easy to use it on others. So what we're going to do is we're going to go to the website for CodeLite, and you can see I've already got a browser open and I've typed in codelite.org. That's codelite.org. And you're going to get a website. And as I've said before, websites change over time. What we're going to be looking for is a download link. Now, at the time of this recording, CodeLite 14.0.0 was just released. So this is the latest and greatest, and that's what I'm going to install right now. So I'm going to look for a download link. You can see obviously this big green box right here. You can always go to the downloads as well. So I'm just going to click this, and that's going to take me to a page where I can donate to the developer if I choose to. I'm just going to select the download link right here. And we're looking for the OS X version. And you can see it's the third one down here, CodeLite 14.0 app bundle for OS X 10.15, which is Catalina. I'm going to select that, and that'll start the download. Now, I've already done it before, so you can see that I'm doing it right here. So I'm just going to cancel that download because I've already done it. And I'm going to come up here to my downloads link. And you could see right there. Now, you can see that it's downloaded as a .tar.gz file. Now, if you're not familiar with that, the GC just means it's compressed. And the tar means that it's an archive. So it's really very, very similar to a zip file, if you're familiar with that. So what we need to do is we need to decompress it and untar it. Sounds complicated. All you need to do is double click on it. So I'm going to show it in Finder. And you can see right here is the file. So all I'm going to do here is double click on it. Okay. That's really it. And you can see the CodeLite application is now good to go. You can see the icon. Don't worry about this file down here. That's just the recording file that I'm using. So all we need to do now is grab that and drag it into our applications folder here. So I'm going to select it and just drag it down to my applications. And that's it. It's now installed. Now we just need to run it. So what I'm going to do to run it is I'm just going to come up here. I'm going to close my browser and get it out of the way. I'm just going to come up to Go, Applications, and select CodeLite. I could also type it into Spotlight Search, but there's CodeLite right here. Now, if I try to run it, which I just did, you sometimes will get this message. CodeLite cannot be opened because the developer cannot be verified. This is pretty normal. It all depends on what your security settings are like. So you can move it to the trash or you can cancel. Well, I don't want to do either. I don't want to throw it away and I don't want to cancel. But what I do want to do is run it. So what you can do is you do cancel here and then come up to your system preferences. And let me close this down just to get it out of the way as well. So you go to your system preferences and you can come to security and privacy right here. And I'll just select that. And go to general. And then you can see right down here, it says CodeLite was blocked from use because it's not from an identified developer. And what we'll do is we'll just say open anyway. And at that point, it's good to go. Let me open it. Here we go. Now it's a little bit different, right? Now it says open. So I'm going to click open and that's going to run CodeLite. I'm not going to do that right now. I'll do that in the next video where we'll configure it to run. So at this point, we've installed the command line tools and we've installed CodeLight. So it's just a matter of getting it all ready to go. In the next video, we'll configure it so we can build a C++ program. I'll see you in the next video. Welcome back. In this video, we're going to configure CodeLight to run on Mac OS X. Now I'm running Mac OS X Catalina and I'm installing CodeLight 14.0.0 in this case. Before we do this, we've got to be sure that the compiler and CodeLight have been downloaded and installed. I did that in the previous videos. If you haven't done that, please go back and do that. So again, I've installed the compiler and CodeLight. Now I'm going to run CodeLight for the first time. You can come up to Spotlight Search and type CodeLight. And you can see CodeLight shows up right here, version 14.0.0, and I'm going to double click that to run it. Now, this is pretty normal. You may or may not get this error message here. This is very common when you're installing software from the internet that's not coming from the Apple App Store. It says the CodeLight can't be opened because the developer cannot be verified. So what does that mean? That just means that you have to allow it to run. Okay, it's a security feature. So what we're going to do is we're going to cancel here. And again, you may not get that message. It all depends on how your system has been set up. Come up to the Apple and go to System Preferences. And then you're going to select Security and Privacy right here. Let me move this to the center here. I'm going to select Security and Privacy. And then in the first tab, the General tab, you can see right down here, it says CodeLight was blocked from use because it's not from an identified developer. Again, all that means is that this app didn't come from the App Store. It came from the internet. So I'm going to select Open anyway, and that will run CodeLight. And again, now you can see I get the same message, but now I get the Open button. So I'm going to click the Open button, and let me close this System Preferences, and that's going to run CodeLight for the first time. And this is what you get the first time you run CodeLight. Now there's a lot going on here. I've got a workspace view over here. I've got a welcome window, and it looks like a wizard wants to run a setup wizard. And I also have this message down here that says CodeLight now offers a better editor color theme. So again, there's a lot going on. You may or may not get this message down at the bottom about the color theme. If you do, then what I'd like you to do is cancel the wizard. We'll run it manually in a moment and say yes to this fix. So I'm going to select yes right down here in the bottom right, and I'm going to click yes. And it says a CodeLight restart is needed. Would you like to restart it now? I'm going to say yes again. Now CodeLight will close down and restart, and it should be back in a second. Okay, perfect. Now what we need to do is we need to run the wizard, the setup wizard. That's the one we canceled a second ago. So let's run it manually. We come up to help, run the setup wizard. Okay, I'll do that again. I'm going to select help, run the setup wizard. Now it's important that we do this. We only have to do this one time. Right now, that's it. Once this is done, we don't have to do it again. So welcome to the setup wizard. I'm going to select next. What's my development profile? In other words, what kind of development am I going to be doing with CodeLight? Well, I'm going to be doing C, C++ development. CodeLight supports PHP, JavaScript, Node, I believe. I'm just going to select C, C++ development because that's what this course is about, and select next. Now, this is a really important step. Remember, we've already installed our compilers, so we're going to let CodeLight set up those compilers for us. So we're going to click on the scan, and CodeLight will scan our system for those compilers. So I'm going to select that now, and you can see that 3 compilers show up. Now, that's pretty normal. It's really the same compiler with 3 different names. So this is exactly what we want. If nothing comes up here, then it's very likely that you didn't install the compiler. So go back to the previous videos and install your compiler. I'll select next. Here you can customize your colors. I'm just using the defaults here. The dark, the light, the gray, whatever you prefer. Again, I'm just selecting the default. I'll select next. For white space and indentation, I'm just going to leave these defaults as they are, and I'm going to select finish. Now we're done. CodeLight's going to close up and open up again, and our compilers and our environment should be set up. First thing, we need to verify that the compilers were indeed set up correctly. So we can do that by coming up to Settings, Build Settings, And then you can see right here under the compilers tab, when you select GCC, we're going to use GCC. Now, the important thing is that when you select GCC and compilers and then tools, you see stuff here. We see those paths here. If there's nothing here, then again, most likely something went wrong with your compiler installation. Okay, so that's it. I'm going to select OK, and our compiler is set up. Okay, so CodeLite, as I mentioned, is an integrated development environment, which means that we can build and run and debug our C++ programs. It uses a workspace model. So the idea is that we can create a workspace, and we create workspaces on this left side here. You can see workspace view up here. And then we can add multiple projects to a workspace. Now that's pretty cool. We can have one workspace and a whole bunch of different C++ projects within it. A lot of other IDEs don't work that way. They basically just allow you to work on one thing at a time. So this is a pretty nice model here. Now, in order to do that, we need to create a new workspace, right? There's nothing here. You can see there's a lot of space here, right? There's nothing going on. So what we're going to do is we're going to create a new workspace. We can do that by clicking right here on this button, New Workspace, or I can come up here in the menu bar and click Workspace, New Workspace. Again, I could use either one. I'm going to select this button right here, and then I get this Select Workspace Type dialog box. I want to create a C++ workspace. It's really important that we choose C++ here, and I'll select OK. Now it's going to ask me, where do you want to store this workspace? I'm just going to put it right in my user directory's Documents directory or Documents folder. And what's my workspace name? I'm just going to call it First Workspace. Here it shows you the complete path to where this file, firstworkspace.workspace, is going to be stored. If you want to put it somewhere else, you can just click these three buttons and choose whatever folder you like. I would encourage you to select that little checkbox down here. That way it creates the workspace in a separate directory. That way when we create multiple workspaces, they'll be nicely organized. Now, word of warning, do not use spaces, special characters. In other words, don't use spaces like this here. Don't use special characters like pluses and ampersands and all kinds of weird things. And don't use any international characters either. Those will cause all kinds of build issues. Keep the naming really, really straightforward with everything we do in CodeLite. Also, if your username, you can see my username right here is my first name and last name. If your username has spaces or if it has special characters or international characters, then put your workspace somewhere else. Create a new folder somewhere that doesn't have that and just store it somewhere else or off your root directory. We're good to go here. We're going to create the workspace. Now, when I click OK, you're going to see this workspace, first workspace, appear right up here in the workspace view up in the top left. So I'm going to click OK. And here's my workspace. You can see it right there, first workspace. You can see this whole area here on the right has been cleared out. In and of itself, the workspace really doesn't do much for us. It's really a container or a holder for projects. So what we need to do now is to create our first project. And we can do that by selecting the workspace and then right-clicking on it and selecting New Project. Okay, so I'll do that again. We're going to right-click on the workspace and then select New Project. And now we're going to get a new project wizard. And this is really important that we get this right. There's a lot of settings here, and depending on how we fill them out, our projects may or may not build. So I'll go through this really slowly and carefully. This is the path to our workspace, and it's asking us for a new project name right here. So I'm just going to call this Project 1. Again, no spaces, no special characters, no international characters. Make sure that this checkbox is checked. Create the project in its own folder under that workspace. That keeps them nicely organized. The category, we're going to select console. The type, we're going to select simple executable G++. Right there, you can see simple executable G++. Don't choose anything else. The compiler we're going to use is GCC. And the debugger we're going to use is different from the ones that we use on Windows or Ubuntu Linux. Those of you who are using multiple operating systems, we're going to use the LLDB debugger. That's Apple's debugger. And then the last thing, and this is probably the most important one, is the build system. We want to be sure that we select default. Okay, default. So I'll leave this screen up for a second. You can pause the video, and I'm going to go through this one more time while you do that. We've got our workspace up here. We've got the name of our project that we're going to create. Again, no spaces, no special characters, no international characters. You're probably tired of hearing that, but it's really important because the majority of build errors that I see in the QA forums is because students put really strange characters in there or spaces. So don't do that. Make sure that this checkbox is checked. The category is console. The type is simple executable G++. The type is simple executable G++. The compiler is GCC. The debugger is the Apple debugger, LLDB. And finally, the most important one, the build system is default. When I click OK, you'll see a project created over here under the workspace called Project 1. Oop, and I put a special character in there by accident. That would have been not good. So let me select OK. And here you go. There's the project, Project 1. You can expand these or contract them by selecting the chevron. You can see Project 1 has a source folder in there, and that source folder has a main CPP file. That's our source code. That's where we're going to type our programs into. Now, I can't see it over here because I haven't selected it. So I'm just going to double click main.cpp, and now you can see the source code. Now, this is C source code, not C++ source code. So we're going to change this in a minute, and we're going to write our own. But it's important that you be able to see this here. So double click on main CPP, and that's what you're going to see. Now, this font is a little bit small. So what I'm going to do is I'm going to make it larger. You don't have to do this on your end because it's probably fine for you, but I think a bigger font will be easier for you to see on video. So I'm going to select the font, and I'm just going to make it size, let's make it 18 so you can really see it. I'll select OK, apply, OK, and that should be a little bit better, I think. Okay, so now what we're going to do is we're going to write our very first C++ program. So I'm going to delete all of this stuff right here. And I know you're going to have some questions as I type this. Just type along, follow along. All this will be explained in the course. The importance of this video is to be sure that you can build C++ programs. So again, type along, follow along. All this is going to be explained. So the first thing we're going to type is pound include, followed by a space, and then followed by IOStream in angle brackets. And I'm going to press enter. Now the pound is the hashtag. We call it pound in C++. So again, pound include space, IOStream in angle brackets, or less than, greater than sign in the end. Okay. Now we're going to type our main function. So I'm going to type int, followed by a space, followed by the word main, followed by a left parenthesis, a space, and a right parenthesis. Now we're going to type a left curly brace, and I'm going to press enter. Now you'll notice that the IDE automatically put the curly that closes the right closing curly brace. So I'll do that again. I'll put in a left one, press enter, and you can see it's closed it for me. That's one of the nice things that IDEs do. Now what we're going to do is we're going to type a couple lines of code, and that's it. We're going to type std, followed by 2 colons, followed by cout. Okay, so std, 2 colons, cout, then a space, followed by 2 less than signs, no space between them, and then we're going to type hello testing inside double quotes, just like that. Then another space, 2 more less than signs, and we're going to type std endl, and a semicolon at the end, and then return 0 on the next line, followed by a semicolon. That's our program. So again, pound include IOStream in angle brackets, int main with 2 parentheses there, an open one and a closed one, the curly brace, std, double colon cout, 2 less than signs, hello testing in quotes, 2 less than signs, std, double colon, endl, semicolon, and return 0. It's a lot harder to say than it is to write. Make sure you've got semicolons on the ends of these lines. And what does this do? Well, we're including the IOStream library so that we can do input-output. In this case, we're only going to do output. And what we're doing here in this function is we're displaying hello testing to the console. That's it. And we're putting a new line at the end to go to the next line. Okay, we're returning 0 because main always returns 0, and we'll get to all of this in the class. As they say, stay tuned, more is coming. Now, one of the things that we need to do is we need to save this before we build it and run it. So notice that over here, you see that red bar going between the 1 and the 6 right there? That's telling you that you haven't saved this. So how do you save it? You can come up to File, Save File. Now you'll notice Save File is grayed out. This is a bug in this version of CodeLite, but the command works. The Command S works, which is what I'm going to use. So what I'm going to do is I'm going to press Command S to save this, and you'll notice that this red line will turn green. So I'm going to do that right now. I'm going to press Command S. Notice it's green now. That's because I just saved it. And that's really important that you save it. So our program is written, and we're almost ready to run it. We just need to make a couple of changes to the project. And we'll do that right now. We'll click on the project name right over here in the workspace view. And I'm going to right click it and then come all the way to the bottom of these options and select settings. And now I'm going to get a settings screen for my project. Over here, it says general, and we don't have to change any of this stuff. This is the stuff that automatically got set up for us when we created the project in the project wizard. But what we do want to do is we want to click compiler here, and we want to make a couple of changes to the compiler. So we're going to click compiler and go up to C++ compiler options right here. And I'm going to click right over here on the right. And you'll notice this button with the 3 dots shows up right here. Click on that. And what we want to do here is we want to scroll all the way up here. And I want to be sure that I've selected C++17 right here. Enable C++17. That's important. So I've selected that. Up at the top, I want to enable all compiler warnings. I've selected that. You can see as I click these, and that's a little bug there too, huh? It doesn't show up. Well, as I click these, you can see the commands down here. Right in the command line, you can see the switches. So there's really 4 things we want. We want to see the W all down here. We want to enable C++17 down here. You can see it right there. And there's 2 more. One is optimize for debugging, and the other is produce debugging information. Those are the 4 that we want to have enabled. Once we've got those enabled, we'll click OK, apply, and then OK. So our program is done. Our project is set up. Now you may think, wow, do I have to do these steps every time I create a project? Yes, but we'll create a project template in a couple of videos from now. That way you can create the one template, create projects from it. You don't have to do this ever again. So at this point, we want to come up to build and then build and run the project. What that's going to do is it's going to compile the project and run it. So let's do that right now. And if we don't have any errors, our project will run. Hopefully I didn't have any typos. So I'm going to select that. And our program is running. This is what pops up. This is a terminal window. And you can see this last login information. I'll show you another option for Mac that can come in handy, but you can see right here is the important part. Hello testing. That's exactly what our program did. You can see the hello testing up here. Hit any key to continue. I'll just press any key. That goes away and our program is done. Everything worked correctly. Now down here is the output view. And there's 2 important tabs here. The first one is this one, the output tab. Now this doesn't show you the output of the program. It shows you the output of when we ran the program, of how it's being run. So this working directory here, this is important because sometimes it'll help us understand when we're having problems, something won't run correctly, we can look here. The other important tab is this build tab. Now this one's much more important. This tells us what happened during the build of our project. You can see that I'm running the compiler here, G++. You can see the file that it's running it on, main CPP. You can see those options we set up and so forth. 0 errors, 0 warnings, that's good. What could go wrong? And where do errors show up? Well, the errors would show up right down here. So suppose that I forgot that semicolon right there. And notice that this is red right here now, and the rest is green. So I've made a change. I need to save. So I can press Command S, and I just saved it. It's all green now. And now I've come up to build and run. It's going to give me an error because I forgot that semicolon. So I'm going to run it, and you could see down here that the build ended with errors. Do I want to continue? Well, no, I don't want to continue. I want to fix my errors. So in this case, you can see the red text right here. It says expected semicolon. And if you click on that red text, this little red arrow pops up here and kind of tells you, helps you out. It's like something's not right here. Between the error code and the arrow up here, you can kind of tell what's going on, right? So I'm going to put the semicolon back in, save again. See, got red here, so I'm going to save again, and I can build and run, and it should build and run just fine. Now, common errors that I see in this first program, forgetting semicolons is very common. Some students, when you see these left paren, right paren, sometimes that looks, let me put a couple extra ones there, sometimes that looks like a 0. So students type main 0, and that's incorrect. It has to be a left paren followed by a right paren. And the other thing I see is this word up here gets misspelled a lot. It's IOSteam. It's not IOSteam, it's IOStream with an R, but often that happens. I guess we're used to writing Steam and not Stream. So I'm going to change that to Stream. I'm going to save, and when I run the program again, it'll run just fine. I don't particularly like the terminal window that you just saw. I like to change that in CodeLight. So I like to come up to, on Mac, I like to come up to CodeLight, Preferences here. And then down at the bottom of the preferences, you'll see Terminal. And right now the default is Terminal. That's the one you just saw. You can choose iTerm2 or CodeLight Terminal. I tend to like CodeLight Terminal. So I'm going to select that and I'll run it so you can see what it looks like in this terminal. The problem with using Terminal is that sometimes you get a whole bunch of terminals. It doesn't tend to close correctly all the time. So I'm going to select CodeLight Terminal, apply, select OK. And now when I run, I'm going to build and run a project again. You can see what the CodeLight Terminal looks like. Now it says it needs access to my documents folder. I'm going to allow it. And you only have to do that once. There you go. Hello testing, hit any key to continue. This, to me, this looks a lot cleaner than the other terminal. It has a lot of stuff in it, but it's your choice. You can use whichever one you like. They both work. Okay, so again, I'm going to press any key. So that's it. We've written our very first C++ program. We've gotten it to build. If you have any errors or any issues that are beyond the semicolon and so forth, or you're getting strange error messages, post it on the forum. And you can see here it says a CodeLight restart is needed. That's because I changed the setting. You can just say yes, and I'll say that in a minute. But on the forum, I might say, show me your build output. And what I want is this part right down here. So you could just copy and paste this stuff, or you could just give me a screenshot and post it in the QA forum if you have any errors. And it's really easy to figure it out here for me. And I'll let you know how to fix it if I can. If you follow these settings and write this code like this, you should be just fine. All right, so that wraps up this video. I'll see you on the next video, and we'll start writing some C++ code. In this section, we'll look at how we can create, build, and execute C++ programs using only a simple editor and the command line. All we need on our system is a simple text editor. It's important to note that word processors such as Microsoft Word and Apple Pages are not usually used to enter program code. Instead, we use basic text editors or programmer text editors. These types of editors are much simpler than integrated development environments. We also need an installed C++ compiler like GCC or MinGW on Windows and Apple's command line compilers on Mac. That's it. At this point, we can create the C++ program using the text editor and compile and run it by typing commands into the command line. This may sound intimidating at first, but it's actually quite easy and efficient. That said, this is a workflow that's more commonly seen with experienced developers. However, you may wish to consider this approach if you find the IDEs too complex or too difficult to understand. You might also consider this approach if your computer hardware resources are insufficient to run an IDE. In any case, this is another option that you may use. In the next several videos, I'll show you how to edit, build, and execute C++ programs using only the command line and a simple editor. There will be separate videos for Windows, Macs, and Ubuntu Linux for your reference. In this video, we're going to install the C++ compiler as well as CodeLight on Ubuntu Linux. Now, the version of Ubuntu Linux that I'm running, I'll show you right here. This is version 18.04.4. This is the latest and greatest at the time of this video. I've just installed this, so it's a clean install. There are no compiler tools installed. It's just clean install and update right out of the box. And as you can see, I'm running this on an Oracle VirtualBox. Okay, so I'm going to close this. Just wanted to show you what version I was running. And what I want to do first is I want to install the compiler tools. So I'm going to open up a terminal session. I'll just right click on the desktop and open terminal. And I'm going to make this font just a little bit bigger so you can see it a little better. And that's where we're at. Now, I'm assuming that if you're running Ubuntu, you're pretty familiar with Linux. So I'm going to use the Advanced Package Tool, APT, to install this. The first thing we need to do is we need to type in sudo. Be very, very careful when you're doing these installations. Double check what you're typing. Remember, when we use sudo, sudo stands for super user do. So you are becoming super user, which means you have access to everything. So you can do a lot of really good things and you can do a lot of damage if you're not careful. So be very, very careful with what you type. So the first thing I want to do is I want to type sudo apt update so that we can update our packages. It's going to prompt you for your super user password, which I've just entered, and I'm going to press enter, and it's going to go through and update your packages. Now you can see that all my packages are up to date. Yours might not be, in which case maybe you want to upgrade them with sudo apt upgrade. If you choose to, you don't have to, but might as well keep them updated. So at this point, we're ready to install the C++ compiler. Now I'm going to do this using Build Essential, and that includes the compiler, the libraries, and make. And I'm going to clear this, and you can see first off, if I type G++, G++ is the command that runs the compiler. The compiler is not installed yet. So I'm going to get this little message here that says G++ isn't found, but you can install it like this. So you could say sudo apt install G++. And you can do that, and then you'd have to install sudo apt make and so forth. So I just want to do it all in one shot. And what I'm going to do is, again, let me clear this. I'm going to type sudo apt install and then build-essential. Okay, so again, sudo apt install build-essential. And when I press enter, it's going to find those packages, and it says, do you want to continue? It's going to tell you how much disk space it's going to take and so forth. So I'm going to say yes. And there it goes. It's installing this package. Now, this includes the C compiler, the C++ compiler, the libraries that we need, as well as make, which is a tool that's used by CodeLite behind the scenes. So it doesn't take too long, maybe a couple of minutes. You can see it's about 65% done now. And once it's finished, we'll test it out by typing G++, and we should get the G++ compiler running. Okay, so it's almost done. It's right at 99%. It usually takes a couple of minutes. It didn't take too long. And that's it. We're done. So I'm going to clear. And now I'm going to type in G++ space -- version, version. Press enter. We're running G++ version 7.5. We're good to go. Our C++ compiler is installed and it's ready. The next step is to install CodeLite, and we're going to do that right now. Okay, so now that we've got the C++ compiler installed on Linux, we're going to install CodeLite now. So I'm going to move this terminal over here, and I'm going to open up a browser. I'm going to open up Firefox in this case, and I've already gone to codelite.org. So that's the website we want to go to, codelite, codelite.org. You can see right here. Websites change over time, as I've said before, but we want to look for the download link. We can see it up here, and we can also see this big green button right here, which is the one we're going to use. So what I'm going to do is I'm going to click on that button, and it takes you to a page here where you can support the developers if you wish, or you could just say not now, take me to the download. I'm going to go there, and I'm going to find in the CodeLite 14.0.0, and that's the current release as of this video. I'm going to look for the Ubuntu Linux Debian releases right here. And what we're going to do is we're going to click on there. And what we're going to do is we're just going to follow these steps verbatim to install it. And it's pretty easy to do. I'm going to clear my terminal over here. Be very careful. Again, we're using sudo here, so we want to be sure that we type these things correctly. Actually, I'm not even going to type them. I'm just going to cut and paste them or copy and paste them. So the first thing we want to do is we want to come right over here and add the public key that we need. So I'm just going to copy that and I'm going to paste it right into the terminal here and press enter. It's going to ask you, well, it didn't ask me for the password because I had just used it before. So we're good here. We've got the key that we need. Now we need to get the repository that's proper for our release of Ubuntu. I'm running Ubuntu 18.04, which is Bionic. So this is the one I want right here. And what I want to do is I want to copy this line right here, and I want to replace the EOAN universe with Bionic universe. Okay, so depending on which version, which distribution release of Ubuntu you're running, you could use Buster, Bionic, EOAN, and a whole bunch of others down here for CodeLight 13. So what I'm going to do is I'm going to copy this guy right here. And I'm going to change this line right here to Bionic Universe. And put the quote mark at the end. So again, what I'm typing is this line right here, except I'm using Bionic in place of EOAN here. Okay, so I'm going to press enter. And it's going to go off and do its thing. All right. Now I'm just going to say sudo apt-get. You don't have to say apt-get. You could just say apt, but I'll say apt-get because I'm going to follow these directions exactly like they are. I want to update. Again, let it do its thing. And then finally, this line right here, I'm going to say the last one, which is sudo apt-get install codelight. So again, all I'm doing is following these directions. So I'm going to press enter here. And it's going to do its thing and install codelight. It's going to say, do you want to continue? I'm going to say yes. And this will take a couple of minutes. You could see the percentage down here. It's about 21%. Just let it do its thing. Don't interrupt it. And when it's done, we should have codelight installed. And while we're waiting for this, codelight, as we can see on the web page, and I've talked about this before. Let me go to the codelight webpage again. Right, here's the main page. Codelight is a cross-platform IDE that works with C, C++, PHP, and JavaScript. It's a very small, lightweight, very good, complete IDE, and it runs across all of these platforms, which is really, really nice. That means that if you learn it on one platform, you know it on another platform. So it's really easy to switch between Windows and Linux and Mac and everything else. So we're about 62% now. Okay, so we're done. It took probably 4 or 5 minutes on my machine. I sped up the video so you wouldn't have to wait that whole time. At this point, codelight's installed. In the next video, we'll configure it so that we can write C++ programs with it. I'll see you in the next video. Welcome back. Now that we've installed the C++ compiler and the codelight IDE, it's time to run codelight, get it set up and configured so that we can start writing C++ programs. So the first thing we're going to do is we're going to run codelight. Now remember, we just installed it in the previous video. If you haven't installed the compiler or codelight, please go back to the previous video and do that. So what I'm going to do, I'm just going to click on my applications down here, and I'm just going to type codelight, and you can see the icon here. If you right click on it, you can add it to your favorites over here on the left side, but I'm just going to double click it to run it. Okay, now the first time that codelight runs, you may get this message down here at the bottom that says codelight now offers a better editor color support theme. If you don't, that's fine. It's probably a newer version of codelight. In this particular version, I'm going to click yes. But before I do that, we're going to run a setup wizard. And I just really want to get rid of all this clutter. Let's do this in a specific way. So I'm just going to cancel this wizard. I'm going to run the wizard in a moment, but I'm going to run it manually. And let codelight do its thing here. So I want to fix this now. I'm just going to select yes. It says now a codelight restart is needed. Would you like to restart now? Yes. CodeLight will now close for a second and it'll open up automatically. And you can see that this is the CodeLight interface here. We've got this left side here. We've got all this white space here. Now, it hasn't been configured yet. So we want to run that setup wizard that just popped up a second ago. I want to run that manually. So if you come up to help, you can see run the setup wizard right there. That's what I want to do. So I'm going to select that. And it says, welcome to the setup wizard. Now, we only have to do this one time. We don't have to do this every time we run CodeLight. So at this point, I'm just going to select next. It's going to ask me for my development profile. The CodeLight IDE supports C, C++ development, PHP, JavaScript, and so forth. I'm only going to use C++, so I'm just going to select C/C++ development. Then I'm going to select next. And this part's really important. It says, let us set up your compiler for you. Remember, we've already installed the compiler, but the compiler has to be able to work with CodeLight. And that's what this step does. So we're just going to let CodeLight scan our system for the compiler that we installed. So I'm just going to select this big button right here, scan, and I'll select that. And you can see that CodeLight found the compiler. And you can see there's several compilers here. It's really the same compiler. It's just using 3 different names. That's fine. Just select next. Now we can customize our colors. This is just the color for the CodeLight interface. I'm going to stay with system default because I think it looks better on video. The dark theme is really nice on the eyes, and if you like the dark theme, I'd suggest you do that one because it works great. But like I said, for the videos, I'm just going to keep the default. I'm going to select next. I'm going to leave these settings as they are for the white space and indentation, and I'm going to select finish. CodeLight closes up and then it will reopen again. Now let's be absolutely sure our compilers are set up correctly. You can do that by going up to settings and then selecting build settings. And you can see the compilers have been set up here. We're going to use GCC in our code, but you can see that we've got different versions of the compilers here. And as you can see, the paths here have been set up for us, which is perfect. That was the whole point of running the setup wizard. If these are empty over here, then you really need to run your setup wizard again, or maybe even install the C++ compiler again because something's not right. Now, what do? Well, we need to start writing our code. Well, in order to do that, we need a workspace. The way that CodeLight works is it uses a workspace that contains projects. So each one of our projects is a C++ program, but they're housed in workspaces. So the first thing we need to do is we need to create the workspace. We can do that right here by selecting New Workspace, or we can do it up here by selecting Workspace, New Workspace. Again, either place works fine. So I'm just going to click this button right here, New Workspace, and I get this pop-up window that says, what kind of workspace type do you want to create? Well, I want to create a C++ workspace. That's what this class is all about. So I'm going to select C++ and select OK. And now where do I want to store it? Basically, where do I want to save these workspaces? So in this case, I'm just going to put it right in my Documents folder. And my workspace name is, I'm just going to call it First Workspace. So I'm going to type First Workspace. Now, before I continue, it's really important. I can't tell you how important this is. This is where most of the errors come up with building. Be sure that you don't use any spaces in here. Be sure you don't use any special characters in here. Keep it really, really simple. No international characters. Okay, so I'll say that one more time. No spaces, no special characters, no international characters. Those things cause all kinds of problems with building. So we want to keep the workspace names real simple, and that applies to project names and file names and everything else we do when we write C++ code. It's possible that your username, you can see my username here on my Ubuntu machine is Frank. It's possible that your username may have strange characters in it or international characters. If that's the case, find a different path to store this to. Make sure that all these characters are just really, really simple. So that's it. Workspace, I'm going to call it First Workspace. You can see where it's going to be created, and it's going to create a file called firstworkspace.workspace. That's the name of my file. Be sure you click down here and make sure that's checked. Create the workspace under a separate directory. That'll be really handy because it'll keep everything nicely organized. That's it. Select OK. And you can see right over here on the left side where my mouse is that we've got our first workspace. Now, in and of itself, a workspace isn't really do anything for you. The whole point of the workspace is to add projects to it. And that's what we're going to do now. So we're going to add a project to the workspace. We can do that by clicking on the workspace and then right-clicking and selecting New Project. Okay, so let me do that again. Right-click on on your workspace, New Project. I'll select that. And now we get this New Project dialog. And there's a whole bunch of settings here. And these are really, really important to get right. First of all, we're in the workspace we created. That's exactly what we wanted. So now what's the name of the project? Well, we can have multiple projects in the workspace, as I said. So I'm just going to call this Project 1. Again, no spaces, no special characters, no international characters. Make sure that this check is checked. Create the project in its own folder. That will allow us to have one folder for each project we create. It keeps it nicely organized. Now, these settings here are really important to get right, so I'll go through them really slowly. The first one is category. The category is going to be console. You can see we can create graphical user interfaces, templates, all kinds of stuff. We want to create a console application. That's an application that runs in a terminal window. The type is going to be simple executable G++. Okay, again, really important. Simple executable G++. G++ is the name of our C++ compiler. It's got the G because it was created by the GNU Foundation. So again, simple executable G++. Don't choose any of these other ones or you're going to get all kinds of build problems. The compiler, remember we ran that setup wizard. So now we're going to come to compiler. I'm just going to choose GCC. The debugger, we want to choose the GNU GDB debugger. And then this last one is the most important of all. Which build system do we want to use? Make sure that you choose default. Okay, so I'm going to leave this here for a second. You guys can pause the video and double check, but I'll go through it one more time. Category is console. Before that, make sure that you've checked this little checkbox here. So we've got category is console. The type is simple executable G++. The compiler is your GCC compiler. The debugger is the GNU GDB debugger. And the build system, very important that it's default. Okay, once we do that, we select OK. And what you'll see is over here in the workspace view on the top left, you'll see a project 1 being created under it. So I'm going to click OK. And you can see that our first project is here. See all this white space over here on the right. That's where we're going to be typing our code. So you can expand these little chevrons here. And you can see that our project 1 has a source folder in it. That's where our source code is going to be. And in there is a file called main.cpp. That's our first C++ program. So I want to see that. I want to edit that. So what I want to do is double click it. And when I double click it, it'll show up over here in this white space. So I'm going to double click it. And you can see the source code right here. And this is what we want to set up. Now, what I'm going to do is I just installed CodeLite fresh on this system. This font is a little bit too small for video. It's probably fine on your end, but for video, it's a bit small. So I'm just going to go to settings. You don't have to do this, but I'm going to set my colors and fonts. And let's see, I just want to set my font to 16. Something like that. I'll select that. And I'll select apply and OK. And that should be a little bit more readable for you guys on the video side. All right, so we're almost there. What we're going to do is, this is actually C code and not C++ code. So what I'm going to do is I'm going to delete this code right here. And we're going to write our very first C++ program. And we're going to do that right now. So I'm going to select all this code here, and I'm just going to press backspace or delete just to delete it. Now, I'm going to type a few lines of code. Please just type along, follow along. I know you're going to have a lot of questions. You know, what does this mean? What does that mean? Hang in there. Stay tuned, as they say. It'll all be explained in the course. But first, we need to be sure that we've got our project set up correctly and that we can run. Okay, so let's start. We're going to type pound include and then IO stream in angle brackets, and I'm going to press enter. pound include, again, the pound is the hashtag symbol, pound include space and IO stream in angle brackets. That's a less than and a greater than sign on each end. Then I'm going to type int main, followed by a left parenthesis and a right parenthesis. Then I'm going to type in a left curly bracket. And notice when I typed in that left curly bracket, I'll do that again. I'll type in the left curly and press enter. Notice that the IDE closed it with a right curly. Okay, the IDE will do that automatically for you. It'll match it up. So right in here, I'm going to type std, followed by 2 colons, followed by cout, a space, 2 less than signs, again, no space between them, and then I'm going to type hello testing inside double quotes. Just like that. Again, 2 less than signs and std, 2 colons, and end L. And then right here, I'm going to type return 0. So I'm going to go through this one more time. Be sure you get it just right. Int main, left paren, right paren, open curly, std, 2 colons, cout, all together, no spaces. Then we've got a space, 2 less than signs, hello testing in double quotes. Again, 2 less than signs, and then std, 2 colons, endl. All we're doing is we're including the IO stream library, which allows us to do input output. We're going to do output in this case. And in this case, all I want to do is I want to display hello testing. You can see it right here. I want to display hello testing to the screen. And this is how we do it. We output it to the cout, which is our console. And then we're going to put a new line on the end. That's it. We're returning 0 because we always return 0 from main. I'll talk more about that later on. And that's it. Now you'll notice over here, I've got this reddish orange bar that's going from 1 to 6. That means it's actually red on my system. It might show up orange on video. Sometimes it does. That just means I haven't saved this yet. It's really important that I save my file. So I can come up to File, Save File here, or press Control S. Either way, I'm just going to press Control S and you'll see the color change. I'm going to press Control S and notice that now it became green. That means it's saved. That's really important. Be sure that you save your file before you try to build it. Otherwise, you may not get what you expect. So that's my program. It's a really simple C++ program. It's got some stuff in there that I know you've got questions about. As I said, stay tuned. It's all coming. Now what we need to do is we need to build this and run it. But before we do that, we need to set a few settings for our project. So let's do that. Click on your project 1 right here. Right click on it. And then all the way down at the bottom, we're going to see settings. So select settings. Now you'll notice that the general is set up right here, right? That's been selected. And all this stuff on the right is stuff that was already set up for us from that project wizard, the new project wizard. We don't have to mess with any of that. What we do have to change is we're going to go to where it says compiler right here. And then I'm going to come up to where it says C++ compiler options. And right here, you'll see a -G, a -O, and a -wall, and all this other stuff. I'm just going to click on there. And you'll see a button that pops up right over here on the right with 3 dots. I want to select that button. And now we've got all kinds of options that we can set for the compiler here. We're just going to set a few options. Actually, we're going to leave the same options that are there, but we want to add one more. We want to click right on here where it says Enable C++17 features. Now in this course, I've used mostly C++14, and that's what you're going to see in a lot of the videos. But this version supports C++17, and they're very, very, very similar. The only differences between them are going to be explained in the course, and most of them are more advanced, and they're not going to affect learning basic foundational and modern C++. These are the settings we need to have on. Enable all compiler warnings, enable C++17 features. I'll scroll down a little bit here. Optimize for debugging and produce debugging information. So those 4 settings are what you see right down here on the command line. So I'm just going to click OK, apply, and click OK again. Now finally, we're good to go. Let's run this. We can come up to build, and we can type build and run project right here. That's what I'm going to do. I'm going to select build and run project. And you could see down here, a bunch of stuff just happened really quickly. First of all, the good thing that happened is we popped up this terminal that says, hello, testing. Hey, that's what we wanted, right? That's what our program was supposed to do. And then it says, hit any key to continue. So I'm just going to press enter. There, notice the window popped away, which is what I want. There's two tabs down here that are very important. One is the output tab. This is not the output of your program. This is the output of trying to run your program. So this is what opens up that terminal we just saw. The other one that's really important is this build tab right here. Those are the only two that we generally will use in this class. So I'm going to select build, and you can see right here that your compiler is being executed. You can see those switches, those compiler options right over here that we just set up. And the good thing here, it says 0 errors, 0 warnings. What could go wrong? Well, maybe you forgot this semicolon here. And then notice again that I've got that little orange red right here, right? I need to save that. So I'm going to Control S and save. And then again, I'm going to go to build and run. And notice that I've got errors. Do I want to continue? No, I don't want to continue. But notice my build output. You see the error right here? It's red. If I select that and click on it, it takes me up to the code. And what happened was, here's the error. It's expecting a semicolon. So I forgot the semicolon. Now, if you type this program, again, I'll save it as is. If you type this program exactly like I typed it, you shouldn't get any errors. If you do, and you post in the forum, I might say something like, can you show me your build output? This is what I want to see. Just copy and paste this stuff or give me a screenshot. That way I can exactly see what's going on. Now, typical errors are that. It's forgetting a semicolon, forgetting to put a quote mark here. We've got a quote mark here and we've got another one here. Sometimes students will, these two parentheses, sometimes when they're together, it looks like a 0. Like that, they'll put a 0 in here and that'll be a mistake. So this is a left paren followed by a right paren. And another common mistake is to IO Steam here. I don't know why, but a lot of people do that. So it's IO Steam, that's incorrect. It should be IO Stream. So any one of those will cause an error down here. All right, so that's really pretty much it for this video. We're all set up to run C++ programs. If you have any errors, post them on the forums along with the build output, and I'll get back to you with the fix. Okay, so let's learn C++. In this video, we'll go over the steps necessary to create our own custom project template. The idea here is that we can create our own project template, and then when we create new projects, we can use this template as the starting point. So that way we'll have our C++ file written, all the compiler settings, and all the project settings as we want. The example I'm going to do here is on Microsoft Windows. If you're on Mac OS X or Linux, use the settings that we used in the video where we configured CodeLight. They're going to be exactly the same as we did there. Okay, so let's do it. It's really easy to do. You can see I've got a blank CodeLight interface here, and I want to create a new workspace. So I'm going to select new workspace. Now, if you've already got a workspace that's open, you can certainly use that one, but I want to create a new one. That way you see me do it a couple more times and you get used to it. So I'm going to select C++ for my workspace type and click OK. I'm going to give the workspace a name. I'm just going to call it my workspace, just like that. Make sure that this is checked here. Again, you guys know all about the naming convention, no spaces, no special characters, and no international characters. I'm going to click OK, and you can see my workspace is set up here. One quick tip, you can right-click on my workspace and select Workspace Settings. And then you can go to Code Completion right here, this tab right here, and you can select C++ 14 or C++ 17. I'm going to select 17. And what that'll do is, as you type in the editor, it'll try to figure out what you want to type and really help you out sometimes with some suggestions. So I'm just going to select OK. You don't have to do that, but it's pretty nice to do. All right, so now let's create our project. Just like we did before, I'm going to right-click on the workspace, New Project. What's my project name? I'm just going to call it Project 1 again. Create the project in its own folder. Category is console. Type is simple executable G++. My compiler is my MinGW64 compiler. My debugger is the GNU GDB debugger, and the build system is default. Okay, so everything before has persisted here, which is nice. So I'm going to click OK. And you can see that my project 1 has been created over here in my workspace on the left. And now I'm going to go to the C++ file. I'm going to get rid of this guy that's here, and I'm going to replace it with the code, very similar to the code we wrote before. The only difference is that it says my template instead of hello testing right here. Now this is the code that I want to save for my template code. This code can be anything you want. In this case, I'm just going to use a real simple include IOStream with a main, and I'm displaying my template. Now what we want to do is we want to set up our project settings just like we did before. So I'm going to select project 1, right click on it, go to settings, and I'm going to go to my compiler, and I'm going to set up my C++ compiler options. I'm going to enable C++17, all compiler warnings, optimize for debugging, and produce debugging information just like we did before. I'm going to click OK. Then I'm going to go to linker. And for linker options, I'm going to use -static. That's it. I'm going to apply and hit OK. That's it. We're good to go now. What I'm going to do now is build my project to make sure that it runs okay before I save it as a template. So let's do that now. I'm going to build and run the project. There's my template displaying in the console. Press any key to continue. That's what I want. So it looks like we had a successful build and run. We can click on build down here in the output view. You can see we've got 0 errors, 0 warnings. You could see the switches that we set are all set up. So that's perfect. Now what we want to do is we want to save this project and its settings as a template so that when we create new projects, we don't have to do this over and over again. So I'm going to right click on project 1 and then select save as template. And now we get this little dialog. What's my project name? I'm just going to call this CPP template. Just like that. Now, what's the project category? We can really choose anything we want, but there is one category that's pretty nice, and it's a user template category. And what I want to do is I want to store my template in that category. So I'm going to select it. And then here you can type anything you want. I'm just going to say Frank's CPP template. And select OK. That's it. My template is now good to go. So how do I use it? Well, I need to create a new project. So let's do that again. I'm going to close this up just so we're nice and clean here. And I'm going to go to my workspace, right click, new project again. I'm going to call this project 2. Again, you can name this anything you like. Now for category, instead of console, I'm going to pick user templates. That's where I saved my template. And then for type, you can see my CPP template right here. That's the one I just created. So I'm going to select that. Okay, pretty easy. Now, if you had saved it in the console category, then when you select console and then click on type, you would see your template here. But I saved it in user templates, and it's right here, CPP template. This is filled in for me already. I'm using the MinGW compiler, the GNU debugger, and the default build system. When I click OK, project 2 will show up here, and it should have all the settings that project 1 had because we created it from that template, but we'll double check. So I'm going to click OK. There's project 2. Now you'll notice that project 1 is bold and italicized. CodeLite uses the active project model, which means that it builds and runs the active project. The active project is project 1. You can see that it's bold and italicized. If we want project 2 to be the active project, we can right click on it and set it as the active project. Right here, make active. Or we could just double click on it, which is what I do. I just double click on it. Now you can see that project 2 is the active project. So let's take a look at the source code. It should be that my template string being displayed. There it is. So we've created project 2 based on the template we just created. If I right click on project 2 and I look at my settings, I should see my compiler flags. There they are. And I should see my linker flag right there, the static. So it's exactly the way I want. So you can see it's really easy to create new projects based on this template, and you don't have to set these compiler flags or this linker flag ever again. So that's pretty much it. We can run project 2 now. I'm going to build and run. And there's my template again. Everything's good. If you're not sure which is the active project, which one is running, you can always look over here. It's the bold italicized one is the active project. And then you could also look in your build output and you could see it's building project 2. So if you think maybe you're modifying this source code here, this is the one for project 1, and you run it and you're getting the wrong output, this is probably why. Remember, CodeLite builds and runs the active project. That's really important. And you could see the project right here. Project 2 was the one that was just built and run. Okay, so that's it. We're all set and we're ready to start coding. In this video, we'll use the command line tools to compile and run our C++ programs on the Windows platform. Now, obviously, we need some sort of editor to type in our code. I'm just going to use Notepad, which is built into Windows, and it's really, really easy to use. Couple of things first. I've created a folder on my desktop called CPP Projects. In there, there's another folder called Project 1. Inside Project 1 is where we're going to put our C++ file, our source code. Now, there's nothing in there right now. Okay, I just wanted to show you where I'm going to be putting everything. Okay, so the first thing I want to do is I just want to open up Notepad. And as you know, Notepad is just a real simple text editor. And I want to type in my C++ program right into this text editor. I'm just going to make it a little bit smaller because I'm going to open up another window in a moment. So let's type in that main program that we should probably know by heart now. So I'm going to say include iostream. Then I'm going to say int main, open and close parentheses, open curly bracket. I'll close the curly bracket at the bottom. Remember, this is not an integrated development environment, so it's not really going to help me with syntax or with, closing open brackets automatically and so forth. I'll indent over a couple of spaces, and I'll say std, 2 colons, cout. 2 less than signs next to each other, which is the insertion operator. And we'll say hello Windows command line. And we'll close the string. Then we can also print a new line at the end. Let's do that. So we'll just say std : endl semicolon. That'll just print a new line. It brings the cursor to the next line in the output. Here we'll say return 0, like we always do. And let me just clean this up a little bit. That's it. We're done. We now need to save that program into that CPP projects 1 folder that I mentioned a minute ago. At this point, you have to be a little careful because Notepad works with text files. So it's going to use txt extensions. We don't want txt extensions. We want cpp extension. So I'm going to go to File, Save As, and then I'm going to go to my desktop, my CPP projects, and my project 1 folder. Now you'll notice here where it says file name star.txt, that's what I don't want. So I want to go to Save as File Type and just say All Files. That gets rid of the extension. And now we could just say main.cpp. That's it. So I'm going to save my file as main.cpp, and I'm going to save. Okay, so if I go to my directory structure now, you'll see I have CPP projects, project 1, and there's my main. Now we need to compile and run this. The way we do that, and I'm going to leave this window open on here on the left for a moment. The way we do that is with a command shell or a command prompt. And all you need to do is just run command. And you'll see where it says command prompt. That's what we want to do. We'll just press enter and run it. And we get this window here, and I'm just going to move it over here on the right. That way it's nice and big. Now you'll notice, first of all, I'm in the wrong directory. I'm in the users Frank directory. I want to be in that folder that I created. So we can use the cd command to change directory. In this case, I want to change directory to desktop and press enter. And now you can see that I'm at the desktop. Then I want to change into CPP projects, and you can press tab and it will autocomplete for you. So I'm going to press tab and it'll say CPP projects. And then I want to go into project 1. There we go. There I am. So if I want to see what's in that folder, I could just type dir for directory listing. And you can see right there is my main CPP. At this point, I want to compile. The way we compile is Let me make this a little bit bigger so the whole line will fit on here. We want to use the C++ compiler, the MinGW C++ compiler that I'm assuming is already installed. We need to have that compiler installed. G++, that's the compiler. Now we need to have those options. -W, capital W, all. That turns your warnings on. Then -std equals C++14. That's using the C++ version 14 standard. And then the file we want to compile, which in this case is main.cpp. That's it. Now, when I do this, if there are no errors, it's going to create an executable file called a.exe. So let's do that. Okay, we got a clean compile. Remember, no news is good news, so no messages, that's a good thing. And we'll do dir again. And you can see right here we have a file called a.exe. That's our executable. I can run it by just typing a. And it says, hello, Windows command line, which is exactly what our program is supposed to do. If you want a different name for the output, we can just put another option on the command line. And what I'm doing here now is I'm pressing the up arrow, and it's going to go back through everything I typed. That way I don't have to type everything again. So you can go up or down using your up and down arrows. So what I'm doing here is same thing. I'm saying, call my compiler, turn on all warnings, use the C++14 standards, compile this file right here, main.cpp, and then you can use the -o, lowercase o, and then the name of the file that you want to create, the executable. So let's say I want main.exe or whatever exe you like. And I'll press enter. And let me clear the screen. You can clear with CLS, and I'll do another directory listing. So now you can see I have an a.exe and a main.exe, and I can simply run main. That's it. This is really, really straightforward. If you have issues with IDEs, if you have issues with hardware resources that you can't run an IDE or just don't like IDEs, you could certainly run C++ programs this way. One thing to remember here, when you type your program into an editor such as Notepad, you may have syntax errors. So the way syntax errors will show up, and let me get rid of that semicolon there. Now, if I just say compile again, notice I got a clean compile. How can that be? I took off a semicolon. That shouldn't compile. I forgot to save it. You've got to be sure to save. One of the things that the IDEs do is they kind of do that automatically for you, so you don't have to think about it. But when you're working in a workflow like this, you've got to be sure that whenever you edit your file, you come up to File Save or Control S. Now you can compile again, and there's your error. So this is the way that you would work in this environment. Obviously, since it's not an integrated development environment, it's not going to get a little arrow here that says red and shows you where the error was, because these things are two separate programs that really aren't talking to one another. But there's the error. You can fix your error. If you make another error, let's say you forgot this quote mark right here. Again, I'm saving the program. I just did a Control S, and I can compile again. And there it says, warning, missing terminating quote character. Okay, you can fix that. I'll save again, and I'll compile one more time. We've got a clean compile. We run main. We get the output. Okay, that's great. So that's pretty much what there is to it. It's not a big deal. Obviously, if you type G++, and this is a normal message right here, fatal error, no input files. It's asking me, what do you want me to compile? You haven't told me what you want. But if you get a program not found error, then go back to the installation video from MinGW that I created and make sure that your path is set correctly. Because what's happening is that Windows can't find G++. Okay, so that takes care of Notepad. Now, there's another editor out there, and I'm going to close this real quick. There's another editor that's free. It's called Notepad++, and I've installed it on the system on my computer here. And you can see it's right here, Notepad++, and I'll press enter. This is a programmer's editor. And let me open the file. I had a previous one open, so I'll open up a new one. Let's see, File, Open, and I want to open that C++ file right here. There we go. So you can see that this is doing syntax highlighting, it's doing code folding, it's got line numbers. This is a programmer's editor, and again, it's called Notepad++. It's absolutely free. You can install it. You can do a Google search and install it on your system. Again, it's not an IDE, but it's a more advanced programmer's editor, which is really, really nice. And it's a lot nicer than Notepad. Notepad was never intended to write code with, but you can certainly write code with it. I'd recommend you use something like Notepad or Brackets or Atom or one of the paid ones like Sublime. There's a lot of really good text editors out there that you can find. Okay, so that wraps up this video. As you can see, if you've got issues with an IDE or if you've got issues with hardware resources, don't let that stop you. You can still learn C++ and you can still get your programs to compile and run really easily. In this video, we'll go over the steps necessary to write, build, and execute C++ programs from the command line on a Mac. All we really need is a terminal session and an editor. Now, as far as the editor is concerned, there are a bunch of editors out there. Some of them are free, some of them are paid editors. The one I'm going to use in this example is called Atom, A-T-O-M, and you can download it from the internet. And it's absolutely free, and it's a fine text editor. Now, before I do that, I'm going to create a folder on my desktop, and I'm going to call it CPP Projects. And within that folder, I'm going to create another folder called Project 1. And this is where we're going to store our source files. Okay, so now what we need is we need an editor and we need a terminal window. So let's create both of them. First, let's create the terminal session. So we'll go to Spotlight Search and type terminal and press enter. And what I'm going to do is I'm going to move this terminal over here on the right so that it's docked just perfectly. And I'm going to run the Atom editor now. Again, you can run any editor you like. And there's the Atom editor, and I'll close down some of these tabs here so that we're here from scratch. Perfect. And again, I'm going to just dock this over here on the left side. Okay, so now what we want to do is we want to create a file in that folder that we just created. So let's go to File, New File, and it's going to be a C++ file. So I'm going to save this right now so that Atom knows that it's a C++ file. So I'm going to say File, Save As, and I want to put this on my desktop. In my CPP Projects Project 1 folder. And I want to name the file main.cpp. That's it, I'll save it. And now we can start typing our C++ program. It's really straightforward. That simple hello world program is what we're going to write. So we're going to say pound include. And you can see now that we've saved it as a .cpp file, Atom knows that it's C++. So it's going to allow us to, it's going to help us out with the code highlighting and syntax highlighting. So I'm going to include IOStream. Then I'm going to have my main. I'll say int main, open close parens, and open curly, which it completes for me. And now here all I'm going to say is std, 2 colons, cout, then followed by the insertion operator, which is the 2 last and signs together. And I'll just say any string. I'll just say hello Mac command line. And I'll terminate that string, and then I'll put a new line at the end so that the cursor goes to the next line when we do the output. So that's ENDL. And we'll return 0. That's it. That's the program. We'll save it. Now we need to go over to our terminal to compile and run it. When you open up the terminal, it defaults in your home directory. So you can see if you type pwd, that prints the working directory, which is users followed by your username. That's not where I want to be. I want to be in the desktop folder that we created. So we can use the cd command to change directory. And I'll just type desktop, and you can press tab to autocomplete. So now I'm in the desktop directory. Then I want to go into my CPP projects directory and finally into my project 1 directory. That's where I'm at. Now, if I want to know what's in there, you can just type ls, which gives you a file listing. And you can see there's main.cpp. That's this file we just created in the editor. What we want to do now is we want to compile this file. So what we want to do is we want to type G++. That's the name of the compiler. That'll execute the compiler. Then we want to provide the compiler the same switches that we did in the IDE. So we'll say dash capital W ALL. So that turns on all warnings. Then we want to write dash std equals C++14. That'll tell it to use modern C++, the 14 standard. Now we tell it what files you want to compile. In this case, I only have one, main.cpp. If you have more than one, you would just list them all separated by spaces. But here we've got main.cpp. That's it. That's all you need to do. You press enter. We get no error messages. No news is good news. We'll do an ls again. And you can see that now we've got a new file created called a.out. That's the default executable file's name when you don't provide a name. In order to run this, you just type ./a.out. When I press enter, we should see hello Mac command line. That's exactly what we see. That's this statement right here executing. It's as simple as that. Now, if you don't like the a.out and you want to provide your own file name, you can come up, and what I'm doing here is I'm pressing the up arrow and the down arrow. You can see it's going through what I've typed. So you want to go back to the statement where you ran the compiler and just type a dash lowercase o and whatever name you want your executable to be. And you press enter. And now if we do a directory listing, you can see that main is there. And if you want to run main, ./main. And that's it. We've created a file, a C++ program. We compiled it and we ran it using only the command line, no IDEs. And as I mentioned, there's a whole bunch of editors out there. You can use Atom, Brackets, Text Wrangler, TextMate, Sublime, and there's a bunch much more. You can just do a search on Google and you can come up with a bunch of examples of text editors. Okay, so let's talk about compiler errors now. I'm going to clear the screen here, and I can do that in the terminal by just typing. And let's get rid of that semicolon at the end here. Now, if I run the compiler again, you can see I got a clean compile. That makes no sense because I created an error here by removing the semicolon. Well, the issue is that I never saved this file. When you work with the IDEs sync everything up. So they realize that your source code has changed, so they're going to compile the latest version of it. Here, these two are two separate programs and they're not synced. You're the person that has to sync them together by making sure you save it. So in this case, I'm going to come over here and do File Save or Command S. Now when I come back here and compile again, I'll see the error, which says I'm missing a semicolon. So I'll add that semicolon. Okay. If I put a semicolon in here at the end of IO stream, which I should not have, I'll save it, and then I'll go and compile it again. You can see there's an extra token at the end of the line. It's complaining about it. So I can go back here, Command S again to save, and I can recompile. This time I'll get a clean compile, and I can run my main. That's it. It's as simple as that. If you don't have the resources to run an IDE, or you don't like the IDE, or you feel the IDE is confusing you and not really allowing you to focus on the C++, this is a great alternative. Pretty easy, pretty fast, and you'll be in business real quick. In this video, we'll go over the steps necessary to create, build, and run a C++ program on Ubuntu Linux using only a text editor in the command line. So in this video, we won't be using any integrated development environment. First of all, I've created a folder on my desktop called CPP Projects. And in that folder, I've created another folder called Project 1. This is where we're going to store our C++ program. In this case, it's just going to be a main, a real simple test. So I'd like to close this up. And the first thing we need to do is we need some sort of editor to type in our program. Now on Linux, we've got gedit. So I could just come to search my computer and type gedit. And we can use that text editor, which is a fine text editor. It's real simple. It comes with your installation. There are many other text editors and programmer text editors that you can use, like Brackets, Atom, and many others, but this one is already here, so we may as well use it, and it works just fine. I've gone ahead and gone to Edit Preferences, and I just turned on line numbers, and you can set all kinds of different settings that you like. I made the font also a little bigger so you could see it. So it may look a little different when you start yours. So the first thing we want to do is we want to write this C++ program. So let's do include IO stream, just like we've done before. I'll leave a space and then I'll say int main two parentheses, the open curly, and I'll close the curly while I'm at it. And now we'll just say, we could just press tab. We'll say std, 2 colons, C out. The insertion operator, which is the 2 less than signs, right together with no spaces. And I'll say, hello, Ubuntu command line. We'll close the string. We'll put another insertion operator, and let's put a new line at the end. That way our cursor will go to the next line when we do the output. And that's ENDL followed by a semicolon. And then we return 0, just like we always do. That's it. That's our C++ program. Now, it's important that we save this with the .cpp extension and not a txt extension. The C++ compiler does not like txt extensions, and you're going to get all kinds of weird errors. Okay, so let's do that. Let's go to File, Save As. We'll find where we want to save it. We want to save it to our desktop, CPP Projects, Project 1. That's where we would like to save it, and I'll give it the name as main.cpp. Now you'll notice a couple of things. When I name the file CPP, the editor is smart, so it realizes that this is not a regular text file, it's a C++ text file, so I'll save it. And notice what happened here. Notice the color coding, it knows C++. Again, it's not an integrated development environment, so it doesn't have a lot of hooks to the compiler and so forth. But you can see that now it's really helping me because I can see that my string is terminated. For example, if I get rid of that guy, then that's black, and it shouldn't be black. It should be a magenta color. Right? So again, I'm going to press Control S to save that file. Now we'd like to compile and run it. So in order to do that, we need to open up a terminal. So I'll come back up here and I'll say terminal. And that'll open up a terminal, which I'll pull down just right by here so we can run them together. Now, one of the things that you'll notice is that if you do a PWD, which prints your working directory, I'm in home frank. I don't want to be in home frank. I want to be in this directory right up here that you can see desktop, CPP projects, project 1. So I need to change into that directory. We can use a CD command to change directories. So I want to go to my desktop, and you can press tab for completion, auto completion, and press enter. Then I want to type CD CPP projects, and then finally project 1. And you could do this all in one line if you like. I just did it in 3 steps. So now I'm in the correct directory. If I want to know what's in that directory, I could just type ls, which gives me a listing of the directory. And you can see that my main CPP file is there. That's the one that I want to compile. So let me make this thing a little bit wider just so you can see what I'm typing here. So the first thing I want to do is I want to execute the compiler. So I want to say G++. That calls the compiler. That's the GNU C++ compiler. And I want to set some options. These are the same options that we would set with the IDE. Here, we're just going to set them as switches right on the command line. So I want to say capital W, ALL. That turns on all warnings. Then I want to say dash std equals C++14. That's going to use the 2014 C++ standard, which is the latest one that's out there. Now we supply, what do you want to compile? Well, I want to compile the main.cpp file. Main.cpp. That's it. So it's going to execute the compiler, turn on all warnings, use the latest standard, and compile that one file, main.cpp. I'll press enter. I got back no messages, which is good. As they say, no news is good news. If you have errors, it'll tell you. If you don't, it'll be nice and quiet. At this point, I'll do an ls again to see what's in our directory. And you can see that it's created a file called a.out. That's the common normal file, executable file that's created when you don't say, hey, create main or create some other name. To run it, you just type ./a.out. And there you go. It says, hello, Ubuntu command line, exactly what we typed up here in our program. If you don't want the a.out and you want your own executable, then you can type that in, and I'll show you how to do that. What I'm doing now is I'm pressing the up arrow and the down arrow, and you can go through what you've typed in. That way you don't have to type it all in again. So you want to go back to the statement where you compiled and just type a dash lowercase o and the name of the file that you want to create. So in this case, let's just say main. That'll be my executable. I'll press enter. I'll do ls again. Now you can see that there's a main file right there, and I can now run main, and I get the same output. Okay, simple as that. It really is very straightforward. Now, one of the things that you have to keep in mind, since this is not an IDE, you've got two things going on here separately, right? You've got your editor here and your command line tool here. They're not really synced together. You're the one that's syncing them together. So if I remove this semicolon from my text editor and I compile again, I expect an error, right? I didn't get an error. The reason I didn't get the error was because I never saved the file. You have to be sure to save the file and then compile. The IDE sort of handle that magically behind the scenes. They realize that you've made a change, so it's going to compile the latest changes you made. This is different since they're not in sync. So you want to be sure that you can come up here and say File Save or Control S. Now I've saved it. Now I compile. Now I see the error. So you can see the error is it's expecting a semicolon, which I can replace. If I get rid of this quote mark and Control S, I'm saving again. Now I run. Now I'm going to get a different error, something about a terminating quote character is missing. So I can put that back in, Control S and save, and compile again. And we can run main one more time. That's it. So that's it. It's pretty straightforward. These are the steps necessary when you have a plain text editor and the command line. If you cannot install an IDE for some reason, maybe you've got minimal hardware requirements, or you just don't like IDEs, or you find them too confusing, don't let that stop you from learning C++. You can still use a simple text editor like this and a command line tool, and you can see the command. You can see the command right there. It's really, really straightforward. If you've got multiple C++ files, which we will later on in the course, you just type them all in here. File 1.cpp, file 2.cpp, and so forth. It'll compile everything, link everything, and run it for you. Many times, if you're a consultant and you're working out there, you'll show up at a place and there's no IDE. You're working as a consultant. All you need is an editor and a command line, and you're in business. Okay, so that wraps up this video. In this video, I'll show you a couple of options that allow you to run your C++ programs right in a web browser. Now, this is pretty nice because sometimes you're on the road, you don't have your computer with you, and you want to take the course and try out some examples. Or maybe you had an idea about an example, you want to try it out, but nothing's available. Or to your friend's house, and there's no computer available there except a browser. All you need is a browser to run these. One example is if you open up your favorite browser, I'm using Chrome here, you can type in cpp.sh, that's the URL, and you get the C++ shell. Now, both of these examples I'm going to show you are rather limited compared to obviously running on your own computer with an IDE and so forth, but they're really, really handy when you need to try something out really quickly without having to install a thing. So in this case, cpp.sh is the C++ shell. You can type your program right in here on the browser. And you can see here I've typed in the Hello World program. And you can set options. You can set your C++ 14 options, your warnings to a W all like we have in the examples. And if you want to run your program, you could just select run, and it's going to compile and run it at the same time, which is pretty nice. Also, if the program asks for input, which we'll get to a little bit later in the course, you can set that to interactive mode, so you'll be able to type into the program, which is kind of nice as well. So in this case, I want to run the program, and you can see it's compiling, program is running, and the output is hello world right here, and the exit code is 0, which is our return 0. That's pretty nice. Now, you can get a URL, which gets a URL to what you did, and you can click on that URL and you get the program that you wrote back. So that's obviously it's storing it somewhere. I'm not sure where or how long it's going to be available, but you can figure that out if you like. That's one example. Another example is webcompiler.cloudapp.net. This is a Visual C++ compiler running in the web. It's a Microsoft compiler. And you can see that they've given you a sample program here. Now this text is pretty small. Again, it's a browser, so I'm going to make my browser a little bit bigger so you can see it, and then I'll make it a little smaller again to run it. So you can see here it's including IOStream. It's using a namespace, which we'll talk about a little bit later, and it's outputting hello world. And let me make this a little smaller again. So when you run the program by clicking this purple button down here, there's your output right up here in this black window here, hello world, which is pretty nice. And you can set your compiler flags however you like. So in this case, I'm setting the warnings to all, and I'm setting my standard compiler to C++14. So I'll close that down. And so as you can see, this is a pretty nice option here. We can, if we get a compiler error, let's say we forget that semicolon and we run, then the compiler error shows up down here. It says in function main on line 7 right here. There's a semicolon expected. You actually get a little red little X there that tells you the error is right around here somewhere. So you can fix your error and run it again. And there you go. There's your hello world. So again, these are some web-based options. They're not perfect. You can't really save things and edit and do all kinds of good stuff, but you can run a lot of the programs that we're going to talk about in this class right in the C++ shell on the web. Hello everyone and welcome back. In this video, I'm going to show you how to use the source code files that are provided for you. What I've done is I've provided source code for all the examples and challenges in this course. And they're all located in the last section of the course. So if you scroll down to your course content, you'll see in the last section, and I say the last section, that's where it's at now, but the course could evolve over time. But you need to search for something that says source code. It'll typically be in the last section of the course. So you can see here, section 21, as of this recording, has extra information, source code, and other stuff. So right here, you can see the source code for all the sections. I've clicked on that, and this is what you're going to see. Now, these are links to the workspace files, and they've been zipped up or compressed. And what you can do is you can click on them and download them and then extract them and use them within CodeLite on your end. So I'm going to show you how to do that. So suppose that I'm on section 4 and I want to download the section 4 source code. You can come over here to the source code for all sections. Then you can click right on here on source code section 4 getting started. And I'm going to do that now. And that will download a zip file. And you can see the zip file being downloaded right over here. And it's going to be downloaded to my downloads directory. So I'm going to close up my browser for a moment. And here I'm in CodeLite. What I want to do now is first I want to extract what I just downloaded or unzip it so that I can have access to those files. And then I want to open it up in CodeLite. So let's do that. I'm going to go to my downloads. And there's the zip file that I just downloaded. Now I'm doing this on Windows. The process is exactly the same on Mac or Linux. So there's my section 4. This is a compressed file, a zip file, so I need to extract it. So I can right click on it and extract all. Now you can see the name that Udemy puts on this, section 4, getting started, source code and all that. That's really long. We don't really need all that because the section names are already in the zip files. So we could just put it wherever we want. So I'm going to remove that and I'm just going to leave downloads just like it is like that. Okay. So I'm going to click extract, and that's going to extract the section 4, create a sections 4 folder. You can see it right here. And if I double click that, there you go. Each one of these folders is a project, and this section 4.workspace file, that's the one that we need to open in CodeLite. So I'm going to do that now. I'm going to close this up, and I'm going to go to CodeLite and open a workspace. If you already have a workspace open, you need to close the workspace. You can come up here to workspace and close workspace. You can't open a workspace if there's already one open, so make sure you close it. Okay, so I'm going to open a workspace and I'm going to navigate over to downloads to section 4 right here, the one I just unzipped, and select section 4.workspace right here. Now, when I select open, you'll see the workspace and all of its projects show up over here on the left side here on the workspace view. So I'm going to do that right now. And there we go. We're done. There's section 4 workspace, and these are all the projects within that workspace. Notice that first program is bold and italicized. That means that that's the active project. That's the one that will be built and run by default. Okay, so let's look at the source code for that first project. I'm going to look for my main.cpp file. I'm going to double click it, and there's the source code. So now I just want to be able to run this. So I'm going to come up to build, and I can select build and run project. I would really encourage you to rebuild the project. Anytime you download any kind of project from a website or from the internet, in this case, it's a good idea to rebuild it. So I'm going to rebuild the project. And you can see down here, I got 0 errors, 0 warnings, so we've got a clean build. It's possible that at this point, when you build your project, a little window will pop up and say, what compiler do you want to use? This is going to be true in Linux and Mac for sure. In that case, pick the GCC compiler. That's the one you're using. So if you get that pop up, you pick the compiler you want and you're good to go. Now that we've built this, we can run it. So I'm going to select run. I'll execute, or I could build and execute again. It doesn't really matter. And there you go. Enter your favorite number between 1 and 100. I'll enter 40. Press enter. Amazing. That's my favorite number too. Press any key to continue. Our program ran correctly. And this is the process that you'll use for all of the sections. So that's it. Pretty straightforward. That's the process that you'll use to be able to access the source code that's in the courses. When I take a course, I always like to know what will be covered in that course so I know what to expect. In this video, I'd like to go over the curriculum for this course. The curriculum has been developed in such a way that students with little to no programming background can get started programming quickly in C++. C++ is a very complex language, probably one of the most complex programming languages used today. That doesn't mean that learning the basics should be impossible to grasp. In fact, all programming languages provide the same general constructs that we use to build programs. This is a beginning modern C++ course. There are many topics in C++ that are at an intermediate or advanced level. I won't be covering those topics in this course. My goal in this course is to teach the basics of C++ so that you can write C++ programs that solve problems. More importantly, this course lays the foundation necessary to go forward and learn more advanced C++ concepts. This foundation will also allow you to read C++ code written by other programmers. C++ frameworks are used everywhere. For example, if you want to program games in C++ using the Unreal Engine, then you'll have the background necessary to use their frameworks. If you want to use the popular C++ Boost libraries, you'll be able to use them and understand many of their APIs. Okay, so let's talk about the curriculum and what you can expect in this course. We'll begin our C++ training by going over the CodeLite IDE's interface and writing a C++ program using CodeLite. As we do this, we'll understand how to compile, build, and run a C++ program. I'll also talk a bit about some errors you may encounter. I know what you're thinking. Gee, she's already talking about errors already? I haven't even started learning to program yet and he's talking about errors. Is this going to be that difficult? Don't worry. The sooner we talk about errors, kinds of errors, why they happen, and how to fix them, the sooner errors will become normal and expected. I've seen students get turned off from programming because they get errors. Expect the errors, fix them, and move on. Then we'll talk about the structure of a basic C++ program. I'll explain pound include, namespaces, comments, the main function, cin, and cout. These are the elements that nearly every C++ program will have. Then we'll talk about variables and constants and how to use them. You can't write a C++ program that does much of anything unless it has variables and constants. We'll go over how to declare them, use them, name them, and much more. We'll also discuss C++'s basic types, which allow you to use integers, floating point numbers, characters, and more. Now that we know what variables are, we'll group a bunch of variables together into a collection of variables called an array. Now we'll be storing and using multiple variables, like a bunch of test scores or temperatures for the last 7 days. These collections are called arrays and vectors, and we'll learn how to create them and use them. We'll also learn how to use multi-dimensional structures so we can model things like grids, boards, and spreadsheets. Then we'll learn about strings in C++. Strings are collections of characters, like my name Frank, which is F-R-A-N-K. Strings are used extensively in C++, and we'll go over the basics in this section. In the following section, we'll learn how to write program statements. These statements are made up of expressions. We'll also go over some of the C++ operators like plus, minus, multiply, divide, and so forth. At the end of this section, you'll be able to write C++ statements that tell the computer what to do in order. Now we get to the real powerful stuff, control flow. It's nice to be able to write a bunch of statements one after the other, but to really have power, we need to be able to make decisions and repeat things more than once. This is control flow. This will open up the world of programming and give you so much power. In the next section, we'll learn how to write functions. A function lets us group a bunch of statements into a single construct. It helps us organize our code and think more abstractly. Following functions, we'll talk about C++ pointers and references. You may have heard horror stories about C++ pointers. Don't worry, I'll walk you through how and why to use them, and you'll see the incredible power they give you over your hardware. Finally, now that we know the basics of procedural programming in C++, we'll dive into object-oriented programming, or OOP. OOP is awesome and lets you model your program in terms of real-world objects. C++ is, after all, an object-oriented language, and that's how we want to use it. Once we understand the basics of OOP, we'll learn about operator overloading, which allows us to define how the built-in C++ operators can be defined so that they work with our own classes, so they feel like they're part of the standard language. Then we'll learn about inheritance and the power that it provides. Imagine reusing existing code by inheriting what you need from it and just modifying the parts that you need to solve your problem. We'll wrap up OOP with polymorphism. Polymorphism allows your program to determine its behavior at runtime and really lets you think in the general, so you don't have to be concerned about details. The last several sections of the course are slightly more advanced, but they're so important that I wanted to include them in this course. The first is smart pointers. We'll talk a lot about C++ pointers, since every C++ programmer really needs to understand raw pointers. But C++ also provides smart pointers, which make memory management much simpler and make your program safer to use. Then we'll talk about the C++ standard template library. C++ provides a standard C++ template library with a rich set of containers, iterators, and algorithms that are ready to use. Why reinvent the wheel when you can use the wheels you have? I'll go over the basic STL elements so that you can put them together and solve complex problems. We'll finish off the course by talking about input and output to files and exception handling. Exception handling allows you to deal with exceptional conditions that might occur in your program. What if a file doesn't exist? Or you try an operation and it fails? It's important to understand how to write your code so that it's aware that something has gone wrong so you can recover from it. Wow, that's a lot of material. Some of these topics can be covered by an entire course dedicated just to them. But don't worry, we aren't going to get into every possible option or explain every construct from a theoretical computer science perspective. This course is practical, and it's about learning beginning C++ so that you can further explore this amazing programming language and use it in real-world applications. In the next videos, I'll briefly discuss the challenge exercises and the quizzes that are included in the course sections. In this video, I'd like to take a few minutes and talk about the challenge exercises in this course. Most sections of the course will have a challenge exercise that you can attempt to solve. The challenges will range from simple at the beginning of the course to very, very challenging toward the end of the course. These challenges are programming challenges in which you'll typically be given a description of the challenge and the project files to start you off. In addition to the challenge description, I'll also explain the challenge in video and walk you through the expected output. These challenges are a great opportunity for you to apply what you've learned in each section and code a C++ solution that works and solves the challenge. Once you complete the challenge, you can watch a video of my solution to the challenge so you can compare to your own. Remember, there are many, many ways to solve the same problem, and my solution is just one way, but it will provide a solution to the same problem that you can learn from. I encourage you to make up self-challenges as well. The more code you write and the more you practice, the more comfortable you'll become with C++ and the better your code will become. It's okay if you can't fully complete the challenge. They're not called challenges for nothing. Do the challenges at your own pace, no pressure, have fun, experiment, and keep trying even if you get frustrated. Before you know it, you'll be solving complex problems and creating your own object-oriented programs. Programming isn't just about getting in front of a computer and writing code. There are syntax and rules to follow, best practices, and lots of thought involved. We also have to learn how to handle errors and know what they mean and how to fix them and more. So, we've included quizzes at the end of most of the sections in this course. The quizzes are for you to see how well you can apply the concepts presented in each section and to reinforce the material presented. Some questions are easy and some are more difficult. I urge you to go through the quizzes. I think you'll find them challenging but still fun. Each quiz has 10 questions, and they're multiple choice and fill-in-the-blank type questions. The quizzes are more concept-oriented, where the section challenge exercises are more code-oriented. But sometimes the quiz questions may ask you about a specific piece of code and what you think it displays. I hope you find the quizzes as well as the challenge exercises useful for your learning experience. Okay, Frank, enough talk. Let's get started learning C++. In this section of the course, we'll take a quick tour of the CodeLite IDE interface. It's important to feel comfortable with the environment that we're using to create our C++ programs, so I'll walk you through the major functionality of the CodeLite IDE, so you can get up and running quickly. Then we'll write our first C++ program. It'll be a pretty simple program that simply asks the user for their favorite number and then displays it on the console. We'll use this program to look at the build options provided by CodeLite, and I'll show you how they work and what they do. Finally, we'll introduce some problems into our program so that you can see some of the typical errors and warnings that you'll probably encounter as you write C++ programs and understand them and know how to fix them. That's it. This section's short and simple, but very, very important since it lays the foundation for writing, building, and running C++ programs in the CodeLite IDE. Let's get started. In this video, we'll take a look at the main elements of the CodeLite IDE, or Integrated Development Environment. Now, integrated development environments are really nice because they allow you to build and compile and edit and debug and do everything from a common interface, but they can be pretty complicated as well. Now, the CodeLite IDE is a fairly simple IDE as far as IDEs go. If you use Microsoft Visual Studio or if you use Xcode and Eclipse and others, they're much more complicated and they've got a lot more bells and whistles. But CodeLite's a great IDE for C++, especially when we're learning. So let me go over some of the main elements here. When you first start CodeLite, you have an interface that looks like this. This is the main default interface, or perspective as it's called in CodeLite. Over here on the left, you have the workspace pane, which is this little rectangular area right here. Here, in this large area, we've got our editing pane. This is where we're going to be editing and typing our source code. And then we've got an output pane down at the bottom, and you can see that each one of these has a lot of little tabs in there, and I'll break that up so you can see it a little better. So here we've got a workspace tab, an explorer tab, and so forth. And I'll go over what those do in just a moment. Now, at the moment, there is no workspace at all. So we need to create a workspace, and then we need to add projects to that workspace. So let's do that. Let's create a new workspace, and we can do it right here. We can select new workspace right on the main menu here, or we could go up to workspace, or we could go to file, new workspace. You can choose whichever one you like. I'll choose this one right here, and I'll give the workspace a name. In this case, I'm going to call it section 4 because this is a video in section 4, and that way we can create all our section 4 projects right within this workspace. The path for the workspace you need to provide, I'm going to select my CPP examples folder, which is on my desktop. I'll select that, and this will create that workspace within that folder, and I'll select OK. Now you can see that we've got a workspace here called section 4, and a couple of other things have popped up here. You can see there's a debug drop down, and we'll get to all that in just a bit. So at this point, we need to create some projects. Notice that there is nothing to edit here in this window. It's empty because there are no C++ files ready for editing yet. So let's create a project. This is going to be very similar to the way we created the projects in the installation videos in the previous sections. So I'm going to right click on section 4 workspace, and I'm going to say new project. At this point, I'm going to select that default project template that we created. In this case, I called it Frank Default G++ Project. So I'm going to select that, press next, and I'm going to give this project a name. I'm just simply going to call it Project 1. I'll select next. I'll accept these defaults, which is my compiler and debugger, and I'll select finish. So now you can see I've got a project named Project 1 under my section 4 workspace, and you can see there's the main CPP file. If I double click that, it will open up in the editor, and it's just going to say hello world. We'll get to building and running this in the next video. But for now, let's create another project, because remember, we can have multiple projects in our workspace. So I'm going to go back up to my workspace, right click, do again, new project. I'll use the same template, and I'll just call this project 2. And press next and finish. Okay. So now you can see that we've got 2 projects within the workspace. Also notice that project 1 is italicized and it's bold. This tells you that this is the current project or the active project. Now, I can select the main CPP in project 2, and you can see here we've got 2 C++ files, one for each project. Now, you'll notice that when I select these tabs, you'll notice I select this tab and this highlights right here. So this tells you that this is the main CPP for project 1. When I select this tab here on the right, this main CPP lights up for project 2. If you're not getting that behavior, then this little link right here is probably not selected. If that's unselected, then you'll click on these and this won't change at all on the left side here in the workspace view. So you want to make sure that that's selected. That way it links the editor to the workspace files. So there we go. We can switch between them very easily. So let's change this source code. I'm going to select this file right here, and I'm just going to say hello project 1. And I'm going to save it with Control S or Command S. And I'm going to select this guy right here, and I'm going to say hello project 2. That way we'll be able to see the difference when we run them. And again, I'm saving it. We could also do File, Save. That's it. Now, suppose I want to change between projects. So here, notice that project 1 is the active project. You can select the active project just by choosing it here from the download list. You can see when I hover over it, it says select the active project. So that's as simple as that. You can also double click on the project name. So if I double click on project 2 is now the active project. Project 1 is now the active project. Now, what does active project mean? Well, when I build a project, let's say I come up to my build and I say build something, run something, clean something, and I'll get to all this in the next video, it's going to apply it to the currently active project. It's real important because suppose that now you're here and you're modifying this source code here, and then you build and you see nothing's changed. Well, that's because this project 2 is not active. Project 1 is the active project. So when you build and run, it's going to run project 1. It may seem like this is pretty hard to keep track of, but it's really not. It's really easy to keep track of what project is active. And using this little link editor, you can obviously see which file you're working on. So it's pretty easy to do. There's a couple of other things that I wanted to talk about here. In the editor window here, you can see that we've got line numbers selected. Okay, so that the IDE is displaying line numbers for us. This is handy because the compiler errors will give you line numbers, and it'll also throw you a little error right here. It'll show you a little mark that says, hey, the error's here, which is kind of nice. I'm going to keep the line numbers on for me. You can choose to not use them if it distracts you. But in the course, I'll refer to line number 7, line number 5. That way it's much easier for you to follow along. If you want to get rid of those line numbers, you could just go up to Settings, Preferences, and right under Editor, you could say Show Line Numbers in the margin, and you could just uncheck that. There's a whole bunch of other options. The other thing you might notice is, you'll notice right here to the left of the int, there's a little triangle. That's called a code folding triangle. So if I select that, you can see what happens is, notice I've got active right now, lines 3, 4, well, I've got all my lines, right, from 1 to 8. But when I select that, it hides lines 4, 5, and 6. And you get this horizontal line showing you that, yeah, there is stuff in here. I'm just hiding it right now. This is called code folding. It basically just hides that code. This is real handy when you've got hundreds and hundreds of lines of code in your file and you're scrolling through trying to find things. It's really, really nice to be able to just fold some stuff up. In other words, I'm working on this function right now. I don't need to see all the other ones. I just fold them out of the way. We'll get to use these features later on as our programs get bigger. But if you find yourself in the position where you've clicked on that by accident and you see this line and you're thinking, oh my goodness, where did my source code go? Don't worry, the source code is still there. Again, if you see that horizontal line, just click on that little triangle and it will show it for you. Also notice that the editor uses color coding to display certain things. So for example, you can see that int and return are a purple color. And you can also see that hello project 2 here is in this dark blue color. We've also got things in dark green, light green, and so forth. Also notice that the integer 0 is red. So there's rules that the IDE is using behind the scenes to make it easier for you to figure out what's going on. So one of the rules that is, it's saying, hey, you know what? If you're seeing a reserved word or one of the keywords in C++, make it purple. You can tweak all of this by going to Settings, Colors and Fonts, select C++ here on the left, and you can customize the font that you want to use for your keywords and so forth. I recommend you just leave this alone unless you have a real problem with some of the colors that are there. Okay, so that makes it really easy to figure out what's going on. So for example, let's say I forgot this quote right here. You can see that that entire thing is now a dark blue. That tells you something's not right. So we can always use that coloring to help us out. It's the IDE trying to make life easier for you. The output pane down at the bottom, this is where our compiler messages will be displayed when we build code. You know, it'll tell us what we're building, the status of the build, and so forth. It'll also be handy for doing global search and replaces, both at the workspace level and at the project level. I mean, sometimes you want to change a name from hello to hello there, and it's really easy to do a global search and replace. There's a bunch of other tabs here. These tabs, we're not going to use most of them. I'm basically just going to leave them alone. But if they bother you, you want to get rid of them, you can click on these three horizontal dots right here, these three vertical dots rather right here, and you can select to hide certain things. So let's say we don't want to see the Build Queue tab. Just select Build Queue and it hides it. You can always bring it back if you like. Like I said, I'm just going to leave them alone. But if your screen real estate is small or your monitor is small and you're having trouble, fitting all of this stuff in, this is a real easy way to do it. The ones we're going to use the most are build and output, and obviously search and replace can come in very handy. Okay, now in the workspace view, we've also got some tabs. Now here, I'm going to spread this so you can see it a little bit. The only ones we're really going to use here are Workspace, Explorer, and Tabs. These last three, Tab Groups, CMake Help, and WX Crafter, we're not really going to use them. So what we can do is we can hide those. So again, I'll select the three dots, and I'll hide WX Crafter, I'll hide CMake, and I'll hide Tab Groups. That's it. That makes it a little less cluttered, and it's kind of nice to see it all there. This little drop-down arrow here, if I'm in Tabs and I select Download, I can go to Workspace. If you only have 3 tabs, it's not really a big deal, but if you've got a lot of tabs, then it's real nice to be able to do that, especially when they're hidden and you can't see them in a situation like this. So the last thing I want to do is I want to show you that you can actually move these panes around. Now, this is the default perspective that you get out of the can. Some people don't like the workspace view on the left. They prefer it on the right. So you could just grab the workspace view tab right here and just move it over, drag it to the right, and you'll see it light up. You can see here, if I wanted to put it down here, it lights up. The area that it's going to be in lights up. Again, at the top, you can choose to put it wherever you like. Let's say you like it over here on the right. And some people like this workflow a little better. So now you've got your workspace here on the right and your editor on the left. You could do the same thing with this output view. I mean, suppose I want to put my output view right under my workspace view. I could do that. Now I've got a really large editing area. It's totally up to you, the perspective that you use. This is a real personal decision. I've worked on teams where everybody on the team, teams of hundreds, everybody's got their own way of doing things, so everybody tweaks the environment their way. The nice thing about this is that if you download some project and it's got this perspective saved, you can always come up to perspective and click on default layout, and that'll bring it right back to the default. So I can just select that, and here I am back to scratch, just like it came out of the can. If you prefer your layout to be a specific way, let's say I like it like this, and I want to move this over just a little bit here, and this guy's up here like that. Again, however you want to do it, you can come up to perspective and then save current layout as. So let's just say I want to call this Frank.layout. And I can save it. So I can switch between the default layout, and if I want to go back to my own layout, I can go back to Frank layout. Really, really easy to do. There's 2 layouts that come already pre-configured. One is the default layout, which is the one I've shown you before, and the other one is the debug layout. This is the layout that's used when you're doing debugging. So if I select debug layout, you can see that I've got an output view pane on the left and a debugger pane on the right. And CodeLight will switch to this automatically when you go into debug mode. Again, if you have a better way of doing it that works for you, you can tweak this and save that perspective. So I'll switch back to the default perspective. And we can also use the view options to hide or view different panes. So for example, if I don't want to see the output pane or the workspace pane, I can certainly hide them and view them. I can also do that here by closing up with that little X right there to close up the workspace view. I can also make the workspace view really large by clicking this icon right here. So you've got all these options, and I encourage you to play around with the environment and set it up to a place where you feel comfortable working. Recall we talked about this in one of the installation videos, that we can show a toolbar so we can build and run and save and have all kinds of options by just clicking on these toolbar icons. I'm not going to use that since it really clutters things up for me, and I want to be able to explain exactly what I'm doing. So for example, that icon right there says Run Active Project. That one says Start or Continue Debugger. So they can be confusing at first. I'm not going to use those. I'm simply going to come up here and tell you exactly what I'm doing. So I'm going to close the toolbar down, but again, feel free to use it. And that wraps up this quick tour of the CodeLite IDE. We are certainly going to use more features as the course progresses. In the next video, we'll create our first C++ program that goes a little bit beyond the Hello World program. And we'll use that program to understand how the build process works within the CodeLite IDE. In this video, we'll write our very first program. So what we want to do is we want to create a project. So again, I'm in the Section 4 workspace, and I'm going to right-click on there and say New Project. I'm going to select my default template again, and I'm just going to call this First Program. And I'll select Next and Finish. Now notice that Project 1 is the active project, so I want to be sure that First Program is the active project. So I can just double-click on it, and I can open up that C++ file. That's it. So this is the source code for the first program. Now what I want to do is I want to erase this, and I want you to really just type it in. That way you get used to typing these things in at the beginning, and that's probably the best way to do it, is just to follow along. So let me tell you what this program is about. This program is going to ask the user to enter their favorite number, a number between 1 and 100. And then it's going to display, wow, that's amazing, that's my favorite number too. That's it. Okay, so let's start. First thing we need to do is we need to do #include of IO stream. Now, as I type, I'm going to press IO. Then when I press S, you can see that the code completion is helping me out. It's trying to figure out what I want, and it's giving me its guess as to what I want. And I want IO stream, so I'm just going to select it and close it. There is no semicolon here on this statement. These pound directives, and we'll talk more about what these preprocessor directives are in section 5, but they don't take semicolons at the end. So I'm going to press enter, and now we want to create our main function. Remember, the main function is the main entry point. This is the place where execution begins. So we're going to say int main left paren right paren, and then we're going to put a left curly, and the IDE will terminate that left curly with the right curly. We'll talk more about style as we go, but some programmers like to line up their braces like this. Others like to line them up like that. Right now, it doesn't matter. Let's just line them up like this. All right, so what do we need to do? We need to prompt the user to enter their favorite number. So how do I do that? I do that with a cout statement. So I'm going to say std, 2 colons, then cout, and we'll do the insertion operator, which inserts something into that stream. Remember, cout is typically tied to your console, your terminal, so the user can type things in. And we're going to display enter your favorite number between, let's say, 1 and 100. And I'll just put a colon there. Now you'll notice that you've got a quote mark and then a terminating quote mark. This is called a string. This is called the string literal. This will be displayed exactly as is. Now, this is a statement, so all statements end in a semicolon. Remember, main returns an integer, and that integer is 0 if everything is good. So I'm going to return 0. Right? So if I run this program now, it's all it's going to say is enter your favorite number between 1 and 100. That's it. It's not going to grab the number from anywhere. It's not going to display anything else. we need to somehow read what the user types in on the keyboard. So just like cout writes to the console, cin reads from the console. So what we're going to do here is we're going to say std cin, and now we're going to use the extraction operator because we want to extract information, and it's the same as the insertion operator except going the other way. But now what we're saying is we want to grab whatever the user types in and we want to store it somewhere. Where do we store that? Well, this is where variables come in, and we'll do a lot of talking about variables in section 6. I'll talk about how do you declare them, how you initialize them, the rules for naming them, and so forth. But declaring variables is very straightforward, so let's do that here. What we do is we tell the compiler, remember the compiler is really dumb, it's not guessing, it does exactly what we tell it to do. So what I'm going to do is I'm going to tell it that I want a variable name, and that name is called favorite number. That's where I want you to store what the user typed in. And you also have to tell it what kind of data that is. Is it a string? Is it some big, huge structure? No, in this case, it's just a whole number, an integer. So we're going to say int space favorite underscore number semicolon. That's it. That's a variable declaration. You've just told the compiler that this variable name right here, favorite number, is an integer. Now I can read information into that. So I can say std 2 colons, and again, the std will explain later on, it's a namespace, but we definitely need it here. std cin into favorite number. Now again, I'm going to type fav, and the code completion will try to figure out what I want, so it's going to use favorite number. I can just press enter. Semicolon on the end. So notice what we've done so far. We've included IOStream. Why did we include IOStream? Because we need the input-output libraries. We can't do IO without it. So we're including it. Now the compiler understands about input and output. It understands cout and cin. They are defined in here. Great. So I'm outputting, enter your favorite number between 1 and 100. Now the user is going to type something at the keyboard, and whatever they type, we're going to store it into favorite number, this guy right there. All right, now we just need to say cout, and I can say something like amazing. That's my favorite number too. Here we can do an end line, so we flush the buffers and print out to the next line. That's it. So let's go through this again one more time. We've got a main function. This is the entry point. This is where execution begins. All C++ programs must have a main function. All C++ programs must only have exactly one main function. So when the program begins to execute, this is where it starts. Here I've defined a variable called favorite number, and it's an integer. It can only hold whole numbers. I'm outputting to the console, enter your favorite number between 1 and 100. The user is now going to input something into the console, a number, and I'm going to read it and store it into that location, into that variable, into that box. Then I'm going to say cout, amazing, that's my favorite number too. And I'm just going to print end line at the end. That'll flush out the buffers and move the cursor over to the next line. Finally, I return 0. Everything's good. Now, next thing to do is to build this program. The program's not going to run by itself. We need to compile it, we need to link it, and then we need to execute it. That whole process of compiling and linking is called building. Now, you'll notice that when you right-click on that source file right here, main CPP, you see it says compile. Now, if I press that, it's going to compile our program, and you can see here, 0 errors, 0 warnings. We'll talk about what happens if you get errors and warnings a little bit later. Also notice that we're using the C++ 14 standard, which is what we want to use. That's what we did when we set up that default template, if you recall. What we need to do next is to build the project by compiling and linking. That's going to create the exe file on Windows or the executable files on Linux and Mac. And we'll do that in the next video. In this video, we'll take our first program, which we've compiled to show that it's got no errors, and we'll build it. Now, if you recall, building means compiling, linking together with extra libraries and external files if we need to, and creating an executable file. That's what building is all about. There are several steps involved with building. The first one, obviously, is compiling. If we can't get a clean compile, then there's no way we're going to build the system. So we want to be able to compile and then link to create the exe file. Finally, we can run our executable. So in this case, you'll notice here's the source code. And there's a lot of space in here. Normally, we don't have all this space in here. I just put it in because it makes it a little bit easier for you to read when you're first learning. So let's just keep it like that. This program is exactly the same as it was before. We're asking the user to enter their favorite number between 1 and 100. We're getting that number and storing it in a variable called favorite number. And then we're just saying amazing, that's my favorite number too. So it's really, really simple program. And we've already compiled it. There's a couple of ways to compile. One is you can come to the source file itself, right-click, compile, or you can come up to Build, Compile Current File, and that's only taking care of the compilation. There's also a lot of things you could do at the project level right here. So if I select the project and right-click, you can see that it says Build, Rebuild, Clean, Stop Build, and so forth. Let's talk about clean first. Now, think about this. When I compile a C++ program, I'm converting the CPP source code, this source code you see here, to an object format, right? A machine language or a binary format. That's going to create a .o file or a .obj file, as we mentioned in previous lectures. That's the purpose of compiling. Now, as your programs are compiled, they will have many of these .object files. The clean process removes all those object files and puts your project in a clean state. In other words, source code only, no object files. Now, why is this important? It's important because when you compile your programs and build your programs, sometimes you want to do a clean build. What that means is I want to start from a position where nothing has been built. I just want to clean everything out. Now, when we're working with a single CPP file like here, it's pretty much a moot point because it's just one file. But typically, C++ programs are very large, and you've got a lot of C++ files. Each one of them is being compiled to an object format. And when you say, hey, compiler, build for me, the compiler's only going to build exactly what it needs to build. So if it realizes that this source code already has an object file associated with it, and the source code hasn't changed, then why bother building it again, right? So it's not going to build it. And it does that to be efficient, which makes a lot of sense. But occasionally you want to do a clean that removes all of that stuff. It removes the exe that was created. And then you want to build again. So now we're going to get a clean build. Again, this is really not an issue here when we've got one CPP file. But if you've got thousands and thousands and thousands of files, there can be a significant difference in the amount of time that it takes to do that build. Okay, so in this case, I can come over here to the project. I could right click and I can say clean. And you'll see here the clean is complete. All it did was remove any object files and the exe files. Then I can say build. Now, when I say build, by saying build project here, pressing F7, or on Mac, whatever the command option is, or I can right click on the project and say build. Now what's going to happen here is it's going to go through your project looking at all the C++ files and only build what it needs to build. Okay, now in this case it's going to build everything because it's just the one file and I haven't built it yet, but it's going to not build what it doesn't need to build, and that's important to understand. Rebuild is the combination of a clean and a build. So when you say, hey, rebuild the project, it's going to do a clean, it's going to clean everything out, and then it's going to build it again. For the beginning of this course, all of these are going to be just fine. You can use rebuilds because it's going to be pretty quick. Finally, once we get a build, we can run the project. The way we do that is we come up, again, remember we've got the active project here. I can come up to build and run. Now, if I do that now, we have an option. We can simply execute the exe file if there is one there. Or we can choose to build and execute. I would generally tell you to select build and execute, and probably remember my answer. Don't ask me again. Would be a pretty good idea, because most of the time our files are going to be fairly small, and a build is not going to take any time at all. So we can build and execute. Okay. So that's how you run. Let's say I want to do that now. I'm going to say build and execute, and there's my program. It says enter your favorite number between 1 and 100. Let's say I type in 24, press enter. It says amazing, that's my favorite number 2. Now this time elapsed is how long the program took to run. This is being displayed in the latest version of CodeLight. Prior to this last version, you didn't see that, and I think it's Windows only it's being displayed. I didn't see that display on a Mac. When you run the exe file that's created from the command line, you don't see that. That's just mostly for FYI, so that you can tell as a developer, if there's something wrong and how quick your program's running. Press any key to continue. I'm done. Okay. Now, one of the things that I want to show you, notice this workspace view, which is where I'm at right now. And again, I've got 3 projects here. Each one has a main. Where's the exe files? Where are the object files? Where's all that stuff? They should be there, right? Absolutely, they should be there, and they are there. The IDEs generally hide that information from you because you don't need to know about it, really. I mean, do you care that there's an object file or an exe file? Really what you care about is these error messages and so forth. But we have this Explorer tab, and that'll let you see all that. I want to show you what that looks like. You can click on the Explorer tab, and then you can drag any folder from your operating system, from your file system onto here. So I can just right-click, open folder, and I'm going to select from my desktop CPP examples, that section 4 folder. That's where my workspace is, and I'll select it. Okay. So you can see now if I expand this, you could see a bunch more stuff now. I've got a .codelight folder that has things that are related to my favorites and compilation and refactoring and so forth. I've also got my 3 projects, first program, project 1, project 2. I've got a make file, I've got my workspace file, but let's look at first program for a second. Now you can see a little extra stuff going on, right? Before all we saw was main CPP, now we see all this other stuff. These are the files and the configuration files that CodeLight is using behind the scenes. The IDE workspace here abstracts that out, since you don't really need to know all that information to build your system. It's building it for you. But if you really want to see them, you can, or you can just look right in your file system. Okay. Now, if I look in my first program debug folder, you'll see that there's my exe, first program.exe. You can see it right here. And there you can see my .object files and .d files and all kinds of stuff that's going on. Okay. Now you'll see first program debug. Now what I'm going to do now is I'm going to clean first program, and all of this stuff should be removed. Okay. So again, I'm going to go to build, clean project. Now, if I refresh this view by right-clicking up here, refresh, and go back to first program, you can see it's all gone. The entire debug folder is gone, the object files are gone, the exe files are gone, everything's gone. So now when I rebuild, all that will be created again. And now you'll notice that debug folder, right? Well, if I come back to my workspace, there's my first program. Notice that we've got build configurations here, and there's a couple. You've got debug and release. You can choose either one. We're going to use debug throughout the entire course because that's what we're doing. We're basically developing right here. Release is when you want to release the file to productions for your users to use. So in this case, debug creates that debug folder that you saw a little bit ago. If we do this in release mode, we'll get a release folder as well. So we'll have 2 EXEs. Now the difference is the debug configuration creates object files that has debugging information in them. It's got all those variable names and stuff. So later on when we debug our program, we can have all that information available to us, and it makes us very, very productive, and it really helps us debug and test our code. The release configuration removes all of that stuff, and it does more optimizations, and it just makes your EXE leaner and meaner so that you don't need all that debugging information at runtime. Okay, so like I said, we're going to use debug. You can certainly use this if you like. If you do use this because you're curious or you want to see what's going on, don't modify anything from in here. I mean, as a matter of fact, if I try to open up this make file, you'll see it says auto-generated by CodeLight. Don't change it. Or even if you do change it, we're going to blow it away anyway. Okay, so you really don't need any of that. This is where we're going to be working in the workspace mode, but I just wanted to show you how that clean really works. Okay, so again, let's recap here. I can select first program, right click, clean. That'll remove all my object files in the exe file. I can rebuild, in which case it will clean and build, or I can simply build, and that will only build what needs to be built. Okay, hopefully that makes sense. It's a little difference between them, but it's not, you should understand it's not that big a difference. Now, finally, we want to run. We come here to run. So let's do this one more time. I'll build and execute. Enter your favorite number. My favorite number is 100 this time. Amazing, that's my favorite number too. That's exactly what our program is supposed to do. Now you'll notice a couple of things here. One is, we're really not using favorite number, are we? I mean, the user's typing it in, but we're not really saying, wow, that's a great number, 13 that you entered, or 100 that you entered. And you'll do that in the challenge exercise in this section. But right now, we're grabbing it, we're storing it into that variable, but we're not really using it afterward. And like I said, in the challenge video, you will use it. So that's it. That's pretty much the build process, the compile process, the run process. It's fairly straightforward. If you've got the toolbar, you can click on buttons to do this. But in this course, I'll come up here and do these things, or I'll just right click here and do what I need to do here as well. That's it. Remember, you can also come up to the workspace and right click on the workspace, and you can build the entire workspace or clean the entire workspace. And that'll create exe files for all the projects all in one shot. Okay, that's it for that. Now in the next video, what we'll do is we'll talk about compiler errors and compiler warnings, and we'll mess around with this program a little bit. And I'll show you some of the common errors and some of the common warnings that you could get, as well as why they happen. Now, throughout the course, we're obviously going to see a lot of compiler errors. I make it a point that when I teach, I'm just coding along with you. So I hope I make some mistakes so that you can see some of the common compiler errors. I'm not trying to make them intentionally, but sometimes, you know, you forget a semicolon, or you forget to do this, or this is the wrong type. So that's important that you see these types of errors happening and you can know how to fix them. All right, so I'll see you in the next video. In this video, we'll talk about compiler errors and why they can happen. Programming languages have very specific rules about how to write code so that the compiler can translate that code to machine code. These rules involve both structure and meaning. For example, C++ says that all variable declarations must end with a semicolon. If we don't add the semicolon at the end, or we put it in the middle instead, then we have a syntax error. The compiler is complaining that the structure is not correct. In the first example, we didn't terminate the string error with a trailing quote character. In the second example, we left out the semicolon at the end of the return 0 statement. Both of these are syntax errors. There's something wrong with the structure of the code. Now, these syntax errors are pretty easy to fix, and the compiler errors usually give us pretty good information about what's going on. Semantic errors are a little different. In this case, the syntax or structure is correct, but the meaning of the code doesn't make sense to the compiler. Suppose we want to add two variables, a and b. If the variables are both integers, then this makes perfect sense. But what happens if one of the variables is a person and the other variable is an integer? Does it make sense to add a person and an integer? Probably not. In this case, the compiler generates an error. When we think of compiler errors, we really think about both of these classes of errors. Remember, compilers are very, very picky. Why? Because their job is to translate your code that you wrote into machine code that functions as you said. If the compiler has any problem understanding the meaning of your code, then it won't guess. It will generate an error. Let's head over to CodeLite and see some of these errors. So now I'm in CodeLite, and I created a project called Compiler Errors. And I created it right from our template, so it's just a simple Hello World program. It's just printing out Hello World. Okay. Now what we want to do is we want to introduce some compiler errors into this program so you can see what they're like. Now let's do some syntax errors. Simple stuff like, okay, we forgot this quote right here. And I can save and compile, and you'll see that I'll get an error that says missing terminating character, and if you click on here, it takes you here. Okay. Now, in this case, we've got another error, that says expected primary expression before return. This happens sometimes. The compiler gets confused. It sees that first error, and then it's trying to figure out what's going on, and it goes to the next line, and it says, I don't know where I'm at, and it creates an error. Many times when you fix that first error, many of the subsequent errors go away. So let's put that quote back in. We'll save, and let's recompile. Now we've got a clean compile. So that would be my, my advice when you're first learning. Start out at the beginning, get that first syntax error fixed, recompile, and very likely a whole bunch of other errors just went away. Okay, so that's an example of a syntax error. The compiler is expecting a string, and it knows it's got a rule that says all strings have to have a quote character, a bunch of characters, and then a quote character at the end to terminate it. It didn't see that, it didn't like that, and there's the syntax error. Really easy to fix. Other times, you may have things that are misspelled. So for example, let's say I spelled end L here wrong. I put an extra L in there. Now when I compile, it's saying error, end LL is not a member of the standard namespace. So it knows that cout is and end L is, but end LL is not. So in this case, this error message kind of leads you to the place where the problem is, and you say, oh, of course, I have a typo. So you can fix that as well. Okay. Another example of a compiler error that's a syntax error is forgetting the semicolon here, let's say at the return 0. All statements have to end with a semicolon, so we just forgot it. That violates one of the rules that the compiler knows about, and it doesn't like it. So what we'll do here, again, we'll compile. And you can see it says error expecting a semicolon before that curly. So there's the curly, and it's expecting a semicolon. Sure is because of that. Okay. Now suppose we just say return, semicolon. Now this is problematic because we've told the compiler in our code that main returns an integer. But here we're just returning, we're not returning an integer. So let's see what it says. Let's compile. And it says error return statement with no value in function returning integer. Pretty good statement, right? It's telling you I've got a function. You told me it's returning an integer, but you're not returning any value now. So I can return 0. Okay, so let me show you an example of a semantic error. Something like this. This is perfectly valid. I can return an integer, I can return a string, I can return a lot of things. The problem is that it doesn't make sense to the compiler because you've told it here that you're returning an integer, but now you're returning a string. So let's run that and see what you get. Here you go. Error, invalid conversion from a character star, which is a string, to an integer. So the compiler is trying to figure out, how do I convert that Joe to an integer? I don't know. I have no idea. I'll just throw the error. Okay, and that's up to you now to fix it. So in this case, again, I'll fix it to return 0. Now let's do another one. Let's get rid of that first curly. This is a real interesting compiler error, and I'll compile it and then we'll talk about it. Let's compile, and you can see that I've got 3 errors from that. What's happening is the compiler is totally lost here. The compiler is seeing int main, and then it's expecting a curly, and it's processing more and more stuff, kind of hoping to see that left curly eventually, and it's not seeing it, so it's seeing other things, and it's throwing errors. It's saying, I don't know what's going on before the STD. I've got an unexpected, unqualified something before return. I'm lost. Okay, so when you see these kinds of errors, I mean, this is a tiny little program, and I've got 3 compiler errors. Sometimes you'll compile something, you'll get 20, 40 errors, and many times when you fix that first one, most of them will go away. So in this case, all that's missing is that curly. So I'll compile, and we should have a clean compile now. No, we do. Okay. Sometimes you'll add extra curlies at the end, which again is illegal. So I'll compile. And there it is. Right? Error. I'm expecting something before that token. It doesn't know what you're doing. So we'll get rid of that. Okay, so let's do one more semantic error. Let's say that we've got hello world in here. And I'm going to put parentheses around it, and I'm going to divide it by 125. And I'll put a parenthesis around that. Just simple math. Okay, that's pretty weird. I've got something here divided by something here. That's valid. I can divide 2 things. The division operator, which is that slash, is a binary operator. It works on 2 things, right? So 4 divided by 2 is 2. 8 divided by 2 is 4, and so forth. But in this case, the syntax is correct, but the compiler is going to say, I have no idea what you want me to do here. You're telling me to divide hello world by 125? I don't even know what that means. So let's compile that. And the error is something like error invalid operands. So the division operator, the slash operator, has got invalid operands. There's 2 operands, right? One is a string, the other one is an integer, and it's saying, I don't know what to do here. Yeah. So these are some simple examples of compiler errors. Don't be afraid of the compiler errors. You're going to get them. Don't let them frustrate you. If you have any that you can't figure out, please post to the forums, and I'll be glad to help you out. It's just something that we have to learn to work with because we're going to get compiler errors. We all make mistakes. Sometimes we're prototyping, we're trying new things, and we're getting errors. Sometimes they're just silly mistakes, and they're hard to find sometimes. Sometimes you'll be looking at your own code. I can tell you, this little error here with the end double L, this is a good error message that you got. But if you're looking at this code and you've been coding for a few hours, I don't think you'll see those 2 L's. Most likely, they look like 1 L. So this is the kind of thing that programming is about. One of the important things is getting rid of all these compiler errors. Once we get rid of the compiler errors, then we can test our code and we can look for logic errors and so forth. Okay, so that wraps up this video. In the next video, we'll talk a little bit about compiler warnings. They're a little bit different from errors because they're not true errors, but they're telling you something that you should look out for. In this video, we'll talk about compiler warnings and why they happen. Big tip, don't ignore compiler warnings. We'll talk more about that in a minute. The compiler has noticed a potential problem in your code and it's warning you about it. That's what compiler warnings are all about. It's only a warning because the compiler is still able to understand your code and produce object code from it. However, it's letting you know to be aware that something could be problematic. In this example, we've declared a variable called miles driven, and it's an integer. It can hold any kind of whole number. Then on the next line, we display the value of miles driven to the console. The compiler produces a warning here. It's warning us that you've used the variable miles driven, but you never initialized it. So in other words, the value that it contains could be anything. Once again, don't ignore compiler warnings. Many programmers treat them as errors and fix the potential issues up front. Let's head over to CodeLite and we'll see some of these warnings. So now I'm back in CodeLite and I've created a project called Compiler Warnings. And again, it's a default project, just simple hello world. Now what I'd like to do is, let's use that favorite number variable again. So let's create that here. I'm going to say int space and the name of my variable. Let's call it favorite number. Perfect. Now, suppose I want to print out that favorite number. So I'm going to remove this hello world right here, and I'm just going to replace it with favorite number. So that's all I want to do. I've got a favorite number. I want to print it out. Now, if I try to compile this, syntactically, there's nothing wrong with this program, but there is a problem, and the compiler's warning you right here. It's saying favorite number is used uninitialized in this function. So in other words, you haven't told the compiler what the value of favorite number is. You haven't asked the user to input anything into favorite number, and you're going to print it. The compiler's telling you be careful because anything could print here. And in this case, anything will print here. So let's run this so you can see what it looks like. I'm going to run, I'll build and execute, and look at what favorite number is, 4200971. Probably not what you expected. That's the reason for the warning. The compiler is telling you you never set that variable to any specific value. So when I print it, who knows what's going to be in there. Okay, we'll talk more about that when we talk about variables. So that's one of the issues that you could have. Another issue you could have is, let me go back to hello world here. Another issue you could have is, suppose that in this case now we do assign something to that favorite number. Let's just say favorite number is, I don't know, 100. So look what we've done now. We've created a variable, we've assigned a value to the variable, but we haven't used it. So the compiler's thinking, wait a minute, did you plan to use that variable? Why did you create a variable and not use it at all? So we'll compile, and the warning is variable favorite number set but not used. Okay, so it's telling you, are you sure you want this? There's no reason for you to create a value and then not use it. And similarly, if I get rid of favorite number here and I just do something like that and compile. There's the warning again, unused variable. You've created a variable, but you haven't even used it. So what do you want? The idea is you should have a no warnings policy in your code. You should have clean compiles with no warnings. Now there's many, many more warnings, and we'll run into them when we talk about if statements and looping and assigning and doing math. And we'll talk more about those warnings when we get there. In this video, we'll talk about linker errors and why they can happen. Linker errors occur when the linker is trying to put all the pieces of a program together to create an executable, and one or more pieces are missing. Typically, this can happen when an object, file, or libraries can't be found by the linker. Fixing linker errors can be tricky. Sometimes it's just a matter of getting the paths correct so that the linker knows where the missing pieces are. Let's head over to CodeLite, and we'll force a program to have a linker error so you can see what the error message looks like. So I'm in CodeLite, and I've created a project called linker error based on the template that we use. So all I've got is a main CPP file that says hello world. Now we're going to force a linker error here. This is not something you want to do normally, but I want to do it to show you what the error looks like. So what I'm going to say is I'm going to say extern int c, or let's just say x. And I'll explain all this to you in just a second. And then in the body of the main, I want to try to use that x right there. It's just an integer, and let's say I want to print it out. I just want to print out x. Simple as that. I'm going to save this. Now you'll see if I compile this program, you'll see what happens. I'm going to right-click, compile. I get a clean compile. There's nothing wrong with the program. Okay. But when I try to build and run it, you can see the linker error. This is classic linker error, undefined reference to something. In this case, it just happens to be x. Also, you'll notice that the linker returned 1 here. LD returns 1, which is the exit status. So something was wrong with the link. Obviously, the compile was fine because we got no compiler errors. If you do that again, there's the compile, no errors, no warnings. So let me explain to you what's going on here. Let me grab my stylus here real quick. And what's going on here is I've got my main CPP file here, and it's going to be compiled to main.o, let's say, or main.object. In here, we have a reference to an x. You can see it right there. You can see it right there. So in here, I've got a reference to an x, which I'm going to use. Now, we also have our IO stream libraries. So the linker needs to grab those libraries, and I'll just type IO stream here so you'll know what I'm talking about. The linker needs to put these two together to create my main.exe. Or in this case, I believe it would be linkererror.exe, but you know what I mean. So the compile is fine. We've created our object file. This library exists. The problem is that I've told the compiler here that this x is not in me. It's somewhere else. It's defined by somebody else. Well, obviously it isn't defined by someone else because that kind of forced the issue here. So now the linker needs to resolve that x. It's saying, okay, where do I get that value to print? Because that's what you asked me to do right here, right? I wanted to print the value of x. Where is x? It can't find it. That's the linker error. That's exactly what's going on. And let me build this again so you can see the error message one more time. Let's build it and run it. And there's the error message. It's saying undefined reference to x. You can see exactly what's going on. It can't find x. Now, this is not a compiler error. This is a linker error. That's really important to understand. Linker errors are tricky to fix. A lot of times, the files that you need to link are missing. They're in the wrong places. You don't have to worry about that using CodeLite. In this course, we're going to basically do everything ourselves. But if you're using libraries from third parties, this is the kind of thing we'll talk about in a more intermediate or advanced course. But I just wanted to show you linker errors in case you do come up with one. Post it in the forum and we'll work through it together.